Welcome to part 3 of my series to build my own 3D printer, or like not to build, but to design my own 3D printer. So today we will work a bit on the motor mounts. So basically where the A and B motors that control the X-Y movement sit. And yeah, let's quickly just check where we are at the moment. So last time we built basically the X-axis and we were working on the tool head mount here, and this is basically the design we came up with in the end. I printed it, I kind of like preliminary mounted it with nuts. I kind of wanted to assemble that on stream, like kind of put it together but not quite so we can have the fun of putting in heated inserts, I guess. But the one thing I noticed already is like it's not super stable. Like it's a bit wiggly, like my camera is also not very stable, but yeah, there's a bit of play. So let's see, like once you put it together properly, if this is still a problem. But yeah, so basically the idea was with this open design, right, that like we don't force the exact distance between the two. It sent me down like a bit of a rabbit hole. So I was experimenting with different bearings. Because it's also something we kind of didn't look at. Oh, by the way, yeah, I hurt my hands, so I have this weird stuff. Just ignore it. I do my best to ignore it as well. So these are the bearings we used so far. I got them from Printables. I think I didn't share a link yet, but once I wrap up the project, I will share all the links and things. But basically, the problem with these are that they're like basically modeled one-to-one after the real thing you can buy online. Hey there, Eric Johns. But then basically there's like no like flexibility in it, right? Like it's basically like it fits or it doesn't fit. And my concern is a bit that like they always have a bit of play. They always have a bit of play. Like if you look here, they always like wiggle a bit around. Like even in like a brand new perfect state, like it always like wiggles a bit like on the, well, not on the rail, but like on the rod. That was a bit something that annoyed me. I also, by the way, got where I put those, but I got the metal reel thing, the reel of here in my goodie bag. I got those metal ones. They arrived this week, and I was like really eager to try it out. But we have one big problem. They don't fit at all. So basically, you can kind of like, if I push now, it's on. But basically, what happens, you see it here still. It just like carves into the rod. Like there's like this cut here that's coming from the balls of the bearing. So the problem is basically this is 8.15 millimeters or something, so it's like ever so slightly over 8. And what they need is like 7.99 or something like that. Like they need ever so slightly under 8. So this does not fit together at all. So these are definitely out. So as long as we use the hardware store rod, the linear bearings made from metal are definitely out. I ordered the plastic ones, like not 3D print, but like the proper plastic ones. Potentially they might fit there. Let's see. But for now, like my assumption is as long as we use the hardware store rods, we cannot use any pre-made linear bearings. So I was like looking around a bit more online, and I found these on Thingiverse, and I think that's quite an interesting design, because basically they are a bit flexible. So basically the idea here is most like, or not most likely, but the idea is basically that they can adjust a bit to the rod. I hope that this also will prevent binding. So my idea, or like my thought is like this might prevent binding, because like as the rod kind of like gets a little bit thicker on the spot, like this can just adopt a little bit, and still just like have like some tension on the rod to prevent any wiggle. Problem is those are just, they don't fit at all, and the maker didn't provide the step files. Like they're just like super loose. And the maker didn't provide the step file, so I cannot adopt those. But what I ended up doing then is I created my own variation of this design. So this is the one I made. Kind of has the same principle. I went with like a slightly different design here, but the principle is the same. And then I tried different sizes. So this is one 7.9 millimeters. It's -1. -2 is 7.8. And then we have -3. You see a pattern there. And oh yeah, this one is actually exactly 8. So I just have different sizes and I try them out. The yellow ones are PLA. And then I also made black ones, which are ABS. You can't see it, but it's also -1, -2, and so on. I was playing around a bit, and like I found two things. Like firstly, the ABS I like more, just like they seem a bit more firm. And then the other thing is, and I'm a bit concerned about that. So in the beginning, the -4 was like super stiff. Also, like the ABS are because like the shrinkage of the material. So basically, -4 PLA wouldn't fit at all, and the -4 ABS was fitting snugly. But basically, you see, maybe I have a PLA one to show that better. Yeah, maybe this one's better. Basically, what happens after a while? See if that can focus. Yeah, you see it a bit. So after a while, you see here, this section gets like super smooth. Like this is not, you see back here in this section, there's like a rough texture, just like from the layer in accuracy basically. But in the front, like in the front tips, it's super smooth. And the front tips is basically where the material hits the rail or the rod. You also see like there's a little bit of like indentation here. So basically what happens, and basically what I was just doing for like 10 minutes is just like sliding it up and down the rail. So basically what happens is, because I have the sandblasted rods here, like they're not fully smooth. Hey there, they're not fully smooth, they're sandblasted. And basically this like acts as like sandpaper basically. So as you slide up and down the bearing, it just gets sanded down. And that basically leads to, for example, the -4, or like that's -2, the -4 that was like super snug in the beginning. Like it's super easy. Like in the beginning, like it really had like tension, like you really had to push a bit. And now it's like already on a point where it starts to wiggle around again. Like it's still like it's a nice movement. But still like I feel like they're loosen up all the time. So I'm not quite sure if there's a point where it just like levels out. You know, like that it's like stop sanding as aggressively. But yeah, so that's just like a concern I have with like using those rods now here. But I checked different hardware stores around the area here, and there is one store that sells those as polished. So then maybe that's better than the sandblast that I use at the moment. But yeah, my plan at the moment is basically to finish up the XY motion system. To have like the entire XY motion system that we have X and XY movement. And then I would just like set up the printer with like different bearings and just let it run for like a day straight. Just like 24 hours, I don't know, circular movement or like back and forth, left, right, something like this. And then just see like how the bearings like develop. If there's really like a point where they level out or whether they just like degrade more and more. Yeah, that's kind of like the bearing story. So that's one part. Then the second part, and that's kind of like what I want to work on today. Let me just pop up Fusion. I was busy a bit during the week. I was actually off work Monday, Tuesday, and I couldn't hold myself but work a bit on it. So I was working on those hind corners here. They're not complete, so today basically my goal is to finish those corners up. Specifically, the motor mounts here are not modeled at all. So we need to build the motor mount, and then I want to basically print one, like the left side. This one we just print, and then just see whether we can put it together. The only part missing is basically, we just quickly pop to that file. So this is how it looks. You see I also found a nice spot for the end stop. So this section here is basically what we need to model today. And the interesting part here is that we also need to have a way to tension the belts, right? So on the V0, this is solved in, I think, quite a... let me quickly open the... Could have done it already, but... So in the V0, I think it's quite a clever system, and I kind of want to like carry that over. Hi there, Alex. Oh, I see the chat is again cut off by one message. I don't know if I can ever fix that for good. Let's see. It's like every time I start streaming, like this kind of resets. It's super odd. Hi there, Kublik. Here we go. So basically on the V0, if we quickly focus on the gantry. Hey. If it wants to. Here we go. In the V0, you see there's like this little like wheel here. And as you turn the wheel, there's like the thread basically. You see the part here? And the motor is mounted to that part. So basically, as you tighten the wheel here, basically you pull the motor back, like you pull the motor towards direction. And because the belt goes around the motor here, you tension the belt, you make the belt path longer. 8 viewers, only 1 like, yeah. Actually, like before every stream, I think to myself, like I should recommend or like remind people to like and subscribe, and I never do it. So thank you, Alex. Please like and subscribe. Yeah, so basically, that's a system I kind of want to copy because I think it's quite simple to model, and we have the similar layout in certain sense, anyways. So I think that's good to just stick with what we know that works. The only thing that we need to check here, and it's like I actually like I'm quite interested. It's like how far does the V0 allow you to adjust it? Because it doesn't seem like it's a large adjustment, because it's basically just like here, this like section, right, which is 60 millimeters. So they only allow you to pull out the motor 60 millimeters, which is not a lot. So maybe we can like kind of like aim for the same. And then another thing I totally forgot is we actually also need this part here. This pulley. So let me quickly just save copy as. We just steal it from the design quickly. And then we can later use it in our design. GT2 pulley 20 teeth. Yeah, so basically that's the plan. Let's model up this motor mount, and then while it's printing, we actually have some special stuff to do. Because unfortunately my V0 is a bit sick, I guess. So that's something we need to fix because I desperately need it. For those who remember, I had this like weird extruder issue and it's back. So basically like it just randomly stops extruding, which is super odd. It's kind of okay, like the beta was also messed up, but that's a different story. But yeah, it just stops extruding like periodically, but it's not super consistent in a certain way. Like you see, like here in the middle it was quite a bit. In the beginning there was nothing. In the end you see it a little bit here again. Not sure if you can see it on camera, but there's like a little bit like a different shade in certain lines. It's super weird, and I thought it was the issue we fixed, and seemingly we didn't. Like 2-3 streams ago we were working on the V0, and that was the problem I wanted to fix, and it worked fine. Like it printed all those parts fine, like everything, like this is like all printed on the V0. It was fine, and like yesterday afternoon was just like, oh, out, done. So my idea is just let's rebuild the entire extruder because I have no clue what's going on there. The good thing is like I randomly ordered this Ritka gear like last week, which arrived conveniently today. So let's just swap out this gear basically in the extruder. And I also, somewhere in my mess, have this, which is the other gears. This was meant for the printer we're building at the moment, but so I would just swap out all the gears because yeah, I'm not quite sure. I feel like that the filament isn't really grabbed on, but there's a lot of pressure on filament. So I kind of suspect that the teeth are a little bit worn out on the V0 or something like that. I really hope they fit together. I'm not quite sure if these wheels fit perfectly. But at the very least, this side is then fresh. So let's see. So yeah, that's basically like we model the motor bay, we print the motor bay, and while we're printing, we fix up the V0, and then we also work a bit on the tool head mount. Yeah, that's kind of like the battle plan for today. So I guess, let's start. I'm a bit scared to model this motor mount, to be honest. So basically, just like to recap for the people who just tuned in. So this is what we have at the moment. I built that corner piece on Monday, Tuesday, because it was just like way too much for like one stream. So I kind of like modeled the pieces or like the corner already. And then the idea is that we only like build this part here on the bottom, and then we can also print it like while we're working here. If we would need to print all the parts, it would just be way too much. So all those are there. Just to quickly explain like how this fits together. So it slowly starts to look like a printer. So basically you see the X or like the Y axis kind of is here and here. It's the same clamping mechanism we also have for the X axis. So we just clamp the rods between the black and the blue pieces here. And then additionally, we have like 1, 2 vertical rods that also just clamped in. My idea is to have this rod later to have the bed on the Z movement, basically, that the bed just runs on this rod, and then this one's just as a corner piece. I think technically we wouldn't need 2, but yeah, the idea is to just have this as a corner piece, because then also this aligns with this back rods here, so maybe we can mount like the main board, for example, here in the corner between those 2 rods. Just one idea. Yeah, and then we have this like 2 shorter rods on the back that just connect the 2 corners. And then here you kind of see like, I kind of like mushed those motors in here a bit. But we have a bit of space here in the back. So my idea was, because we go for Bowden setup for the initial run, we can, for example, mount the extruder here in the center. Yeah, so that's kind of like the rough setup. And now basically we just need to like create the motor mount here. Yeah, so let's just stop talking. Let's try to make this happen. Yeah, you also see, as I stop talking, now I'm keep talking. We have 2 motors here. I kind of like just like smashed everything in here just like to have like a rough idea. But basically we have this YB 28BYJ motor, which is the motor we will initially use. So these are like super cheap. They're like €1 a piece. They're super bad, like there's no way around it. But basically we need to mount this one. But later on, I also want to have the option to just swap in like a proper NEMA 17 motor. So basically the motor mount we built needs to accommodate both of those. I think it shouldn't be too hard, because like the hole patterns are like, it's different, right? 4 versus 2. But like the spacing width-wise is relatively similar. So if one fits, we can just add holes for both. Yeah, and then the other part is, at the moment, this is like 2 different parts, right? It's like this blue part here now and like this part. But I don't see a point in making it 2 parts. It's just like you have to add screws, steel space, no point, right? So my idea is just let's have one continuous big part. And then my concept is, you kind of see it here on the side, to have like those like rails basically, and then have just like a piece slide into that rail, and then we can tension with like a twisting knob against this back part here. That's my idea. So I think the first part, oh yeah, and then quickly also just as a setup. So we have those like 2 roller stacks here on the back, right? So basically we will have 2 belts coming in from the Y-axis. One belt, let's just for the moment, let's say like the bottom belt doesn't go to this motor. So the bottom belt just bypasses the front stack and goes to the back stack and then like goes around the corner basically. And the second belt comes in on top goes around the first roller stack. So basically it goes around the first roller stack here, goes to the motor, goes around the motor pulley, and then goes back and then around the corner. So basically we just have this like one that has this detour here around the motor and one that goes directly just around the corner. So that's kind of the setup. Now I would say like, let's just remove this weird stuff I modeled here. Oh, and I love this fusion bug. Sometimes you just have this like loading indicator constantly as a mouse. Let's just see. So yeah, this is basically those features here is what I modeled. But I would say let's just kind of go through and just completely get rid of that. We don't need it now. And then I think this part is called motor bay at the moment. But as mentioned, let's just connect, like, let's not have this as a separate part. But let's just have like this corner piece basically extend and just have everything in one piece. So I think we can actually just go through. There's like a lot of stuff going. It's really hard to click when your cursor is a circle. I have to aim with the top with the top part of the circle. So let's just quickly check like this motor bay component, which one this is. And let's just get rid of that. Yeah, it's this one, so let's just get rid of this. It's actually just... Let's delete this. And then there's like this random body here, and then we can just remove this body. Oh, not like this. Remove. Okay. And then let's just work in the component we have here. So we activate a component, and then let's just isolate so we can focus on this beautiful piece here. But actually, before we isolate, I think the smartest way to start is to first define where our pulley is going to be, right? So we kind of have to determine where we put the pulley. So yeah, let's first do like this kind of like U shape, and then we know where the center of the U shape is. So let's create a sketch. Let's just do something like this. Also, like we don't need this like chamfered corner here. So let's just get rid of this. We can just cut into that, I guess. Just do this. Let's just put everything straight for now. Okay. Actually, not quite sure how thick to make that, but I guess 4 is okay. This doesn't have to be like super strong. And this side can even be less. And on the back, to be honest, we don't need any back wall here. So let's just hook this up here. And this needs to be straight. Yeah, and then we can just extrude that. So these two. Oh yeah, and there's this like cutout here, which I basically just added to save material. For now, let's ignore that. we can later restore this thing. Like this is the body 54 here. You kind of see it. This is like this cutout. So we can just later like apply that on top and then restore it. So let's not worry about like overlapping here or whatever. Let's also remove the corner. Oh no. There's still a blue line. We don't like blue lines. Blue line means basically it's not fully defined. So let's... make sure that everything is black, and then we have this like little lock symbol here. So this we can just remove. We don't want this corner here. Perfect. Okay, so this is kind of like the space we have available. So the next step for me, I think, would be, because now we know where the center is, let's determine where our pulley needs to be. Because like from the pulley position, we will also then kind of determine the motor position in a certain sense. So yeah, I think the best way to do that is to make a sketch. Let's see, let's put the sketch actually on the wheel here, like on this like roller. And then let's just project the left and right side of our bay. Right. And we kind of look from the bottom at the moment. It's a bit complicated. So basically, our pulley now needs to be in the center of this area. So I think we can just create like an arbitrary point for now that is somewhere in the center. This needs to go here. And then this point is always in the center of this line. Now let's be a little bit smart, because we know like the bigger motor we have is NEMA 17. So let's just dimension it in a way already that like for NEMA 17 it will fit. Let me do it. I mean, I have the model, I could measure it, but NEMA 17 dimensions. 42 millimeters. It's a beautiful number. I like 42 millimeters. So let's just say 42 divided by 2. So this is basically the frontmost pulley position for NEMA 17. Doesn't really matter for now, but let's roll with that. Okay. So this sketch, basically this point is the top center of our pulley. And we stole the pulley from the War on Zero design. So we have this pulley model. Here, GT2 pulley. Let's just insert that in the current design. Let's actually just activate the main component. Then we can say insert. And then we have our pulley here. So let's just place that. So we put it upright. It doesn't really matter for now. Like this can just like be somewhere. And then we make a joint. So we just connect this random object with something in our design. So we can just take the circle here. This is like the upper thing. And we can align this with our point here in the sketch. So now basically this pulley is locked in place here. And if we look from the side, so now that's the interesting part, right? this pulley needs to align with our roller here. And you see like the dimensions are ever so slightly different. So my roller basically has like tighter tolerances compared to the pulley. So we should center that. But it's not super important, I guess, that's like exactly center. So we can just add that as an offset here to our joint. So let's just kind of visually center that, because like in reality, like you won't have that in this precision anyways. So this is our pulley. Now that we have pulley, we can also determine the motor position. Let's work with the NEMA 17 first. I mean, in the end, it needs to work with the NEMA 17, right? And our like weird ass wonky little motor. Let's just do the same shebang again. So we have the NEMA 17 motor, which I stole from the Ender 3 design. Let's just already put it upright. And then let's make another joint. So I'm kind of like, let's just use the top of the shaft here, and this goes here. And now we have our motor in place. Let's just lock that in for now. So the interesting part A is, I mean, it's not quite center, which is interesting. Oh yeah, you see, it's not quite center here. Let's quickly fix that. So wait, let's quickly delete this joint again. Oh yeah, see, there are two. We selected the center of the face, but not the center of the circle. We want the center of the circle, of course. And now it's center. Okay. So the good news is it just fits in our motor bay. So we just gave it enough space. How much is it actually? Like from the edge of the motor to the side, it's, oh, that's mighty tight. So let's just go back to our sketch here. Because we gave it this 4 and 2, let's just make this side 1 millimeter. It's just like to add a little bit more thickness there. And now basically you see like we just gained a bit of space left and right on that motor. Oh, Eric, I missed your strange message. I'm not quite sure what you're referring to now. But I'm pretty sure it's strange. Okay, cool. So this is kind of like how the motor would sit here. The only thing is we need to consider that like on the opposite side, right, the pulley needs to be basically flipped around, and it still should work. I'm also we need to consider that the bed problem you mentioned earlier. Oh, okay, sorry, then the message was super old. Yeah, we'll figure that out later. Sorry for missing that message for so long. Yeah, so basically like on the opposite side, right, like the pulley will be flipped around basically, because like we then not use the top roller here, but the bottom roller. So I don't think we can position the motor so deep that we can just have the pulley down. And we can just test it, right? So I know that it would be like, so we have this like offset of 0.25, but then it's like plus 10. 8? 8. So this would basically be the position, like the pulley position on the opposite side. You see now the lines with the bottom one. I mean, now the motor also like moved down. Let's actually put the joint of the motor also on that. No, I can't do that. Maybe just like try if we find like a position of the motor. Where basically on both sides it works. That we basically have the same motor position, but then we can just adjust the pulley up and down. And I think that actually like, I mean, this is like mighty close, but if we just move the motor down, let's say like maybe 2 millimeters. So this would now work on the opposite side, right? But then here on this side for the top roller, it also would work. The only problem then is basically we are now requiring a NEMA stepper with like this long shaft. Because I know that some NEMA steppers have shorter shaft. Yeah, this is 22 millimeters of shaft length. Let's do a quick web search. Let's see what AliExpress. My trusted source for steppers. And I'm pretty sure that's, yeah, this one for example looks to have like a shorter shaft. I'm not quite sure if they specify that here. See, 23. This one has 23. Cut the shaft. Now I think like the shaft can't be too long. I'm just concerned that some NEMA steppers have shorter shafts. And then like our like motor layout wouldn't work. Let's just do like another one. This one has 20, for example, which would be fine. I just ran into that problem with the switch wire build because the switch wire, or like the endo wire, the way they laid out the motors, some stepper motors from the ender didn't work because the shaft was too short. Like they required you to flip the pulley on the head, but then basically the shaft wasn't long enough to secure the pulley against the shaft. Oh, but that's actually a good one. Creality stepper. Let's just check out the stepper for that exactly had that problem. I just want to prevent to have the same problem. Exactly, it's a smaller stepper that had a shorter shaft. But it doesn't look like it on the picture here. I mean, I have them here, they're just like built in. Let's see, do I have dimensions here? But also this looks like 20 millimeters for sure. And it's the, not the 40, it's the yeah, there's the 24, 34, which is the less tall one. Yeah, okay, let's just roll with it for now. Yeah, see here, this one definitely has a shorter shaft, I think. Man, I had to like pull off those pressed pulleys. Like pulleys are pressed on with like a interference fit. That was like an absolute pain. Okay, but then let's just assume this works and then let's roll with it. Okay, then this motor position works for both sides, which is perfect. Just as a last sanity check, from, let's say, the top of this like ring here to the base plate, it's 18 millimeters. Which is a bit short then. So basically the shaft, yeah, it goes a little bit above. Okay, if we have to change this later a bit, doesn't really matter. So let's work around this. So basically my idea is to have two things. So firstly, like we need to create like some body where the motor is mounted to. And then my idea is to have like small indentations left and right where the motor just runs in as a rail, and then we can tension it by pulling it out. And the good news is, like, even looking at this, so we know that we said the V0 allows 6 millimeters of adjustment, which is pretty much exactly that. So we don't even have to like prolong this like a lot. That's good news. Okay. So we're working on this sketch here. So let's just draw some very crude shape. So my idea is to have like something like this. I'm not sure if this is really really clear, but basically let's, so this one has a 45-degree angle, 135, yeah, and then this one as well. So basically just have this like one shape. No project name yet. Choosing names is the most fun part. Yeah, like I don't have a, like I have two names. And like if somebody has a great suggestion, like I'm open to it. Like my internal working name, that was kind of like the initial idea. I call it Moron Zero because it's just like a super stupid concept. So and it's kind of V0 sized. So that's my internal working name. And I think the video series I now call Poor Man's Core XY. Also have that here. But yeah, we need some fancy name. But I didn't come up with something yet. So I think it should be something that is very affordable, achievable, but kind of like cool in the same way. You know, like yeah, I don't have a good idea. That's my main problem. Let's just keep like 2 millimeters to the side here, and I think while this should be a little bit beefy from the thickness, yeah, 4 should be fine. And then those two should be identical. And then let's keep the center 2, and then we kind of get like a shape slowly. Let's do the following then here. So let's just make a center. And now we can basically just say this piece here is symmetric with this piece here along this, and this is symmetric with this along here. And the center part is symmetric with this along here. And now we just need to like constrain it on the side. So I don't want this to go super deep into the part because we have this like clamping mechanism here. And there are also some screws going through, so I'm kind of like curious to see if that works. So let's just put ever so slight overlap here. So let's just say 0.4, whatever, like really, really small. Actually here, like we also, you know what? Let's actually just put this directly on the edge, if this is possible. So that only like this like chamfer part basically goes into. Wait, why does it not work? This one works. Why don't you want to put this there on top? Oh, because the constraint on the bottom, yeah. Okay. That's semi-smart. Okay, so now this is kind of okay. So now let's just put this on top of the motor. So let's just quickly project this body here. And then let's just say our tolerance is set to 0.2. So I just have this as a variable. And now we have this beautiful thing here. So let's just create, oh, that was, so I just put this as construction lines, then it's like one continuous thing. Actually the same here and here, and then it's like one shape. So let's just take this all the way to the end and just create a new body. And I think the second part would be to, firstly, we also have to cut into the outer part, right? So let's combine this body with that body and set the operation to cut. And we want to keep that inner part. So now we have this rails basically in here. The only thing we need to do, we need to like push this out a bit, right? Because right now it's like a perfect fit, which in reality is not a thing. So let's just select those, and then we say we pushed it by tolerance. I think this creates something weird. Now it creates a fillet. That's not really what I wanted. Let's do it via the sketch, I think. So let's just create a slightly larger version of that. And then instead of combining, we extrude the larger shape to the back, and then we cut this body. And now we have this little slider thing here. Perfect. So the next step basically would be, let's like the shaft obviously goes through the part that doesn't work, but we also need mounting holes. So my idea would be to project this. And then the other thing is, it's also project the body itself. And those we can all set as construction lines. What I would do then here is just, let's create like some U shape. So this is the center. And then we can just create like a circle. Oh, not directly in the center, please. Sometimes super hard to see those blue lines on the gray body. And we can mirror that line along the center line. Okay, now we have this U shape. We just have to like dimension it a bit. So here are the mounting holes, which actually, like, what is the diameter of those? Exactly 3. So we need a bit more. So let's just say this is, I have like stuff like this all as like variables. Oh yeah, screw diameter actually includes already like tolerance, so it's 3.3. So let's just create this one, and then we just say circular pattern around that center here, and we need 4, and then yeah, we have 1, 2, 3, 4 holes. Then the question is just like, how far should this be apart? Let's just say maybe a bit more, 3, something like this. And from the back, maybe you can really just choose an arbitrary number, maybe not 15, but 17, something like this. And now we can select this, and this, and then we say we cut to the bottom. And if we now put in our NEMA motor, this already starts looking like some motor mount. There's enough space for everything, like for the center part. And then the other thing is, right, it's actually like also a good one, like we want to have this like mount as short as possible, right? Because we want to pull it back. Right now we can't pull it. So that's actually also something we can do in this sketch directly. So let's kind of cut this off. Then yeah, so basically let's assume we make this shorter, so that needs to be like more, of course. Why can't I make this 20? 25? It doesn't like 25. Why can't I do 25? Oh, we also see there's a problem. This needs to be connected here, please. Not quite sure what it's doing here. Let's just delete quickly that circle. Sometimes Fusion is doing things nobody understands. And by nobody, I mean mostly me. Let's just also just put this to center. Let's just say, yeah, something like 5 is fine. And then what we can do is we can just take the end here and say to objects. Not sure if we can reference, or I can reference circle here. Maybe not. Yeah, let's just do it as a fixed number for now. Maybe something like this. Okay, and now basically like we are kind of aiming for what the V0 is doing here, right? So if you look at what they're doing here, like that. Yeah, so these are the printed parts, right? And this is more or less like what we're building at the moment, right? So we have this, yeah, they also went for this U shape, basically. Theirs is way thicker. So we're kind of like in economy mode there. But then they have this like screw thingy here at the back. And that's kind of like the same thing I want to do. Interesting part is it doesn't give me the radius of that. But yeah, basically this is more or less what we're building. The difference is this is for NEMA 14, so it's a smaller motor than what we are aiming for. The reason, by the way, why I don't want to go for NEMA 14 here is that NEMA 14s are way more expensive for some reason. I think it's just like not as much of a volume product as the NEMA 17. So let's see. I mean, we can also just make this thicker behind the motor, right? Let's actually see if we can... Oh yeah, there's this line here actually. Oh yeah. Like instead of like having a fixed length here, let's just say to object and selected motor. Because this is like the motor will like block the backward movement anyways. So this is like kind of like the perfect size. And let's just say, just give it an offset of like 0.5 or something. It's actually tolerance times 2. That there's like a little bit of an edge here. Okay. And then the question is, if we do it like this, how far can we move now? 6.5 millimeters we can move back. So that's exactly kind of like what we are aiming for as like a couple. So now I was thinking, so let's first model like the thread maybe. Oh, I don't want to mesh. Let's just put this here. Let's see, like maybe, yeah, maybe 20 looks okay. Like it's supposed to be kind of like chunky, right? So let's just make the center here, and then this is below the center or like on the center line. Visually, I think it would be nice if we center that also like on this like motor bay in a certain sense. So let's just make a center point here as well. Oh, I want to point. This is the center point. Like the triangle symbol means center. And now we can say this is on the same height as that. And now the circle is defined vertically by the center and horizontally by the center. So let's just, I mean, this looks a bit odd now, but let's just say 40 millimeters out. Maybe it's a bit much. 30. And then this must not be round, of course, right? We need to print that in some way. So actually, when we go to our extrude, let's not select this bottom top part here. Because this would make it quite difficult. And then also like, because now if we do it like this, we can print it on this surface. So basically if we flip it over, right, we can print it on that surface. But then the top part I think will also be really bad quality wise, because like if you have like a round shape and you print it in this like horizontal orientation, right, like the further you go to the top, the less resolution you have. So let's just do the following. So we cut it also here. And let's just make like a helper line from the center to the side. And then we can just, yeah, actually, let's just do the following. We just mirror this. Let's do what I had. So we have the line here, and then we say symmetric here. And this needs to go onto our circle. So now when we extrude that, we can just skip over the bottom part as well. And now we have this shape. So let's see if we can throw a thread on that. So here it says now this would be an M20 thread. I guess that would work, right? I'm not quite sure if we have like, if there's like something that's like better suited for printing or something. Not sure if anyone knows like a print optimized thread type, I'm all ears. Tapping thread for plastics for sure not. So let's just go with M20. There's also this class where I know the class is like the tolerance. I'm not quite sure if this makes like a big difference for us. I think 4G, 6G is less tight in a certain sense, which is fine. Okay, so this is kind of the part we don't have. Potentially we get away with like having it a bit shorter, but we can change the length later on. So the only thing I don't like is there's not really like a transition from this like thin part to the thick part. But I don't think it will be unstable or anything, right? Because like the only force that like is put on that is like a pulling force basically. So it's like the force in this plane basically, and there you have like quite a lot of strength. I don't see how this would like shear off or something. I mean, I could be wrong, so let's see. So now we need, firstly, like we need this like wheel on the back, right? But then we also need something for the wheel to like press against. If you look at the, again, like the thing we are cloning more or less, right? You see this wheel, like this like thread only comes like through this hole here. And then the wheel basically, as you turn the wheel, you pull this like center part, you pull it back because the wheel tensions against the surface here. So we need something like that as well. And I think there are like two opportunities we have. So firstly, we can just make it a really big wheel that it touches left and right. That would be like an option, right? And we just have like a huge ass knob. But I don't think that's super nice. The problem in a certain sense is that, so this part, because we have this like thing here, needs to be printed on this surface. This is the printing surface. And I really want to have this as one part. I don't want to have like fasteners or something here. Speaking of fasteners, let's actually quickly check, because we have those fastener holes here on the outside. If we look into that part, yeah, I think it's fine. Like, because we cut into the part here a bit, I was concerned that this like heat insert was too close, but this looks totally fine. Maybe we can even make it a tiny bit wider. What's this? This sketch. Maybe we can even say we only add 0.5 millimeters here, and maybe we can make this 3.5, just to have a bit more wiggle room with the motor, so the motor walls are not directly on that. So what we could also do, I mean, we said this is like 6.5 millimeters, right? 6.9. Maybe that would be cool. Like if we extend this, let's say by 10 millimeters. We have plenty space there, so that's fine. So we just pull this 10 millimeters out. And then what we could do on the side, because like we have shitloads of this like rod, right? Maybe we don't even have to print this like surface. Maybe we can just do the following. We go over here. And just punch a hole through. Actually, like, let's say, diameter, like ref 1.5. Hey, that doesn't fit on top. My idea was like to just have like, just for like visualization, let me quickly do that. Distance to object. And let's not cut that part. An offset, say -2. That was my idea, to just have a hole here, and then just like to put the rod through that hole, like as a, I don't know what this is, like 6 centimeter piece here. And then you have one on top, one on bottom, and then you can run the knob on the rod, which I think like would look good, but doesn't fit, which is a inconvenience. It doesn't fit. On the bottom it would fit for sure, but on top, I mean, you're missing not a lot. We're missing not a lot. Because it doesn't need to be like super deep in the material. So let's say this is, yeah, let's, just want to check if we can make it work. Then we have to move the motor down. And that's problematic, right? No, that won't work. But we can make a combination. Because we are printing on this surface here, right? So what we can do, maybe let's protect the body instead. Oh, it's all still, okay. We just need this vertical position here. So maybe we can just say, we just make like a small corner piece here. Oh, no, that's not what I wanted. Like a corner piece. Let's just say this is above this like screw surface. It doesn't need to be super tight, tolerance times 2 is fine. And width-wise, let's just say 8, something like this. And then we So we just do this. Because like we are printing on the surface, so we can just easily do that. That's not a big deal. The problem is on the bottom part, we can't do the same because like if we print in this orientation, right, then this would be like a huge bridge. I mean, most likely it would be fine. I mean, what we can do here, right? We can basically pick up this line and further it like to the center, like just like as an overhang, 45 degrees. And then we can just bridge the center part here. Because like all you need to do, right? You need to be able to slide this gray part in, and then you can put the motor in later. Like this can be closed off. So basically the assembly order would be like you take the gray part, you slide it into this like slot, you put the motor on top, and then you fasten the motor like from the top. And then you put on the knob. So I think this will work. Let me just get rid of this. And let's also, just for simplicity, actually not sure what we prolonged this, okay. Just for simplicity, let's work before we model the thread, because then it's like a simpler geometry without this like thread thingy. So let's just jump here. And basically we can just draw like a rectangle. Right, and then we just dock this here on the other side. We attempt it at least. And then we say this is tolerance times 2. Again, like doesn't need to be super tight. And then here we just basically go up here like this. Let's just connect this side. And then let's just grab the center on here, and we can mirror those two parts. And we just need to say this one is above the center. And then here as well, right, we just say this distance is equal to this here on the side. And then we say this is a 135-degree angle. So it's like a nice 45-degree overhang. And then we select both. I guess we said 8 millimeters deep. Oh, that's the wrong direction. So it's minus 8, and we also want to have the bottom part. And then we can say join. This looks good, I think. The only thing like we kind of need to like manage still is like we have this cutout here, which is body 54. So we kind of have to reapply that in a certain sense. We just can't really apply it all the way through, right? Because now we're cutting through our back surface here. And the only place we really disturb it is here with this like side thingy. Okay, let's get rid of this wall here. This comes from the very first sketch. We have 0.5 here. So let's just get rid of this distance. and this attaches directly here to the corner, and everything will be broken now. Oh, sometimes I'm very proud of Fusion. Sometimes you change something like this and it's like complete mayhem, and sometimes it's, yeah, sure, whatever, here you go. Cool. Wait, now the cutout is gone. See, it did screw up. Now I selected this part. We don't want to select this part. Here we go. Below 110, that's nuts. Below 110 what? Oh, you mean the price? Yeah, well, it will be like quite a interesting printer. It will be quite an interesting printer. I can tell you that much. So basically don't expect like any like high performance machine. Like my goal is it prints parts that are somewhat acceptable. This is, by the way, what we have so far. I think it looks cool. Like, just because it's cheap doesn't mean it needs to be ugly. And also, like, keep in mind, like, there's two caveats kind of like in the pricing. There's two. There's one. Basically, I don't include the filament costs. So the filament's kind of like on the side extra. So that's kind of like the thing. So it's just like the parts you need to buy. It's kind of like 100 euros or like $110. It's kind of like the what I'm achieving for. But also, like, we use those like teeny tiny stepper motors. Actually, I'm sure if I have one flying around. Like, we don't use the proper stepper motors. Because if you buy the normal stepper motors, just the motors will be like $30-40. So we use those small ones, and they're like quite weak, of course, and they also have quite a bit of backlash, which will impact the printing quality quite a bit. But basically, I want to design the printer in a way that you can upgrade parts. So basically, we are designing, or like, I will build it now with those, but when we are done, I want to just upgrade to like the normal NEMA steppers. So basically, like, my goal is like the cheapest base price would be like below 110, but then it's not like a usable machine. Like, it's a usable machine, but like not a nice machine. I also won't have a heated bed and everything. Like, you really have to cut out anything, and then you can just add things on top as you go. It's definitely lovely. Well, filament is free, right? Yeah, of course. I actually got one free spool of filament from printables. Like, you know, like you can collect on printables the meters. Like when you like upload makes, upload files, whatever. And like I uploaded so many makes because every time I made something, I just uploaded a picture of it, that I got a free spool of Pusherman Patchy, which was really nice. Yes, I'm using these steppers. But yeah, again, like, so the base version for 110, like the goal is it's printing. It's not it's printing fast or it's printing pretty. It's just printing. But yeah, it's the thing, right? Like if you buy 4 steppers, like NEMA 17 steppers, and like 40 euros are just gone, and then like you really don't have like any budget left for anything else. So basically we use those steppers. I use those like aluminium rods from the hardware store as the motion system basically. But then again, like I will design it in a way that you, instead of like having the hardware store rods here, you can like swap in proper smooth rods and proper like linear bearings, and you have like a better motion system. Hot end will be the Creality hot end, because like this entire assembly with like the Bowden tube and everything and 5 nozzles for whatever reason costs 6 euros. So it's the cheapest hot end available, I think. We still use like a nice Voron tool head, so you know, you don't have to cheap out on everything. And then mainboard, the only option I really see is like you get like secondhand Ender mainboard for like, yeah, $5 to $10. So we use the Ender mainboard, and then we'll run Marlin basically in the base version, but you can of course flipperize a second motor because 2 different motor models are fun. So if you just go back, Let me actually quickly save because I have really trust issues with Fusion sometimes. Like it crashes sometimes, or it has like weird glitches, and like yeah, it's a cool piece of software. It's very complex, and as a software developer, I understand the complexities, but it's sometimes it has its moments. Okay, so if we just go back slightly where we were here, so this is the NEMA stepper, but we also, of course, need our 28 BYJ48. Oh, not import new. Insert into current design. So let's just add a mount for that too. Oh, that's nice. It's a great idea for it to be upgradable, but frankly, I'm very interested if you can run with all these tiny steppers. Do you know like the channel Print Made with Layers is the new name? Thomas Landerer. He's like OG like printing YouTuber. He made a review last week or the week before on like a very, very cheap printer, which like on AliExpress you get for 70, 80 euros. And they use exactly those steppers. Because like at this price point, this is the only option. And again, like it's not great, right? Like, it's super shit. Don't get me wrong, like don't expect like a perfect printer with that. But it's possible. And also like in the first installment of this series, we already made the stepper work with the normal printer mainboard. We hacked it in a certain way, because by default they are unipolar, so they have 5 cables. But the printer mainboards only support 4 cables. And I don't quite understand the physics behind that, but basically by removing the 5th cable, and you have to like mod the motor in a very slight way, you create 2 different coils for the stepper, and then you can double the voltage. So now we can run it at 12 volt, which also doubles basically the torque and performance of the motor. So these are better than stock, but still, yeah, let's see. So my hope is basically that the tuned motors are even better than the motors used by the printer reviewed on the other channel. I didn't watch it well enough to notice that they use these. Very cool. Yeah, you really just see it like ever so slightly, but like it's this model of motor. Like if you just like step through the video, like they show up. For some reason they have white covers. Which I didn't really see on AliExpress. Like the normal ones always have, I moved the cover from mine, but you see it here, like this part here is always blue, like this cover here on the back. And the ones in this like 70 euro printer, for some reason is white, which might be indicating it's a different model, but it still has 5 cables from what I can see. So it's still a unipolar stepper, so it's weaker than the tuned ones most likely. Okay, so let's figure out how we incorporate this stepper as well. So I want to have one mount for both motors. Potentially we have to have 2 printed parts, but whatever we design needs to work with both. Okay, so the challenge here is the shaft is really, really short. So compared to the NEMA 17, which has like a really long shaft, we have a really short one here, which means that this motor sits on top of the build plate, not build plate, of this mounting plate. And I noticed that before, like if you assemble this motor, like it comes together in really weird angles. So we kind of have to level this out, I think. Let's actually measure that. Can we... 6 point... But is this in 3D? No. Okay, so the angle is 6585. So whatever we have here as an angle, minus 6858 degrees. Wrong direction, plus. Okay, yeah, perfect. And then like the thing that we can cheat a bit, hydrorevonic. Revonic, like we talked about the bearings last week, right? I received the metal bearings. Big problem, they don't fit. Like this is how far it goes. Now it like is in contact with the first ball and I can push it on now. But it actually like marks the rod. The problem is, kind of makes sense. These are meant to be on rods that are like 7.99 millimeters, like ever so slightly under 8. But these here are 8.2, like they're like a little bit oversized. It's hardware, so like it's not meant to be used for that. So this does not fit on the rod, so they are out. I do have the not the 3D printer, like the plastic ones en route. They should arrive next week. But I'm pretty sure that they have the same problem, that they also don't fit. So I'm actually like, I showed at the beginning quickly, like I modeled my own one that is a bit compliant. And these seem to work quite well. So maybe this is like the way to go. I still like want to, I choose the length of the rod in a way that you can basically just order like normal smooth rod and like swap it in basically. So potentially, like for the super cheap 100 euro version, we definitely go with the hardware store solution. But then if we upgrade that machine, we definitely need to swap in like proper smooth rods. But yeah, they're not super expensive, but again, it's like 10 euros on top. So it's like 10% of our budget. But yeah. You mean... Abstract, you mean those? You get them for 2 euros per meter in the hardware store. Like this is like dirt cheap. It's just aluminum extrusion. It's hollow. Yeah, you get them for 2 euros. That's the cheapest I saw. So like $2 per meter. That's why I use those for the entire structure of the printer, because it's just dirt cheap. And the benefit is like they are 8 millimeters. So my idea was that you can use like standard bearings. But yeah, you can't. But still, like you can always order these, and you also see like it's not expensive. This is not the real price. I'm not logged in on AliExpress, and then they always show like ridiculously cheap prices. But I know I have it in my basket. As soon as I know the length, I will order some. So we most likely will need the 300 millimeters one for the X. And there, yeah, it's like 2 euros per piece. So for all 6, it's like 12 euros for all the linear rods. And then you can use proper bearings, which will upgrade the motion system dramatically. But yeah, so for the sub 100 euro version of this machine, we will use the super cheap steppers, we will use 3D printed bearings, and we use hardware store rods. So yeah, but then still it's designed so you can swap in like proper parts later. Okay, so now the fun part here. So firstly, like we can move that up. I think 2 millimeters. I'm just trying to close that gap here. Yeah, something like this. So this is for this side, right? But on the opposite side, remember, this is 8 millimeters lower. So we need to have 2 versions here basically of this mount. So now it's quite simple, right? We just add mounting holes basically for the stepper, and we can just no, yeah, we can make it as a separate body. So firstly, we have one problem. The stepper collides with our plate here, which is not great, of course. So, I mean, the thing is the pulley doesn't have to be here, right? The position here along this axis, we just chose for the pulley that the stepper, the big one, is on front. So we can just decide that we have like an offset here for this motor of like 9 millimeters, something like this, right? And then like for, if you use the small motors, the pulley will be further to the front, but doesn't really matter. That's not a big deal. So now basically we have to adjust our U shape to accommodate this bigger motor here. And let's actually just move it just 10. So basically, yeah, we have to make this a tiny bit bigger. Hi there, Slim Knight. I've used those super cheap steppers before. Are you doing the hack where you break center lead? Yeah, we do that. Where we actually have, we've done it with one. This one is our test sample. This one has that mod done where we break the center lead. There's two reasons. Like A, it of course makes it way stronger. But B, the stepper drivers that come on printer main boards, they only have 4 pins, right? So without the hack, this has 5 pins. So we cannot drive this motor with the stepper driver from the printer main board. So you need the hack to make it happen. I'm not sure if you make them less accurate, actually. I don't fully understand the physics behind that thing, but I did not read that you make them less accurate. But we will try it out and see what happens. But yeah, it's not an option to not do the hack. Like if you want to use a motor with a printer main board, you do the hack. That's the only way to do it. Nice, yeah, did the same thing. You could use a separate external driver. Yeah, you could, but I kind of want to have it simple and easy. And I have actually like this Ender 3 mainboard flying around, which I have nothing to do with, so that's a perfect opportunity. Plus the Ender 3 mainboards are super cheap. You get them secondhand for like 5 to 10 bucks. I believe it's as accurate, but for 3D printing application, it is negligible. Yeah, most likely. Like the precision with these won't be great anyways. Because they have quite a bit of backlash, like on the shaft. Like when you're off, you can like rotate the shaft like quite a bit, like maybe like half a degree or something. Yeah, Bomb with Links is coming, and also like everything will be open source. Like once we're done. At the moment, this is the status. So there's still like a lot missing. Cool. Okay, so basically what this means is, because we need to print this part on this surface here, right? The blue surface, so we cannot extend that. But the fun part is also, we have to have the pulleys on 2 different heights. So this is the upper position, but the lower position, if we just quickly simulate that, is 8 millimeters offset. And now we discover a problem, because now our motor is inside that plate. So we have a problem. Have to go, but we'll definitely follow the dev of the printer. Thank you. You should make a Discord server that could be cool to follow there too. Yes, I could actually. I did not consider it yet. But I also post on YouTube, like if you subscribe to the channel, so just a reminder to everyone, like and subscribe, please. I will also post like updates there, so you can also follow there. Once I get more time, I'll probably send you an update on my Ender 3 cross country. Please do, Revonic. Very interested in that. Cool. Okay, so let's solve this. So that is a bit of a bummer. How much are we missing there? Let's quickly hide the NEMA 17 and focus on the small one. So if we select this surface, I wonder whether we can mount it from the bottom in this case. Wait. Here, where's the body? You are the body. So we are 1.2 millimeters into the part. We can make this part thicker and then just like have the motor sit inside. That would work. Can we make this part thicker? This is the sketch we use here. So here's what I'm thinking. So we have 4 mounting holes anyways for the NEMA 17. So I'm thinking whether we leave the plate as is, but then like now add a cutout that the motor kind of falls through. And then we design a small part that like mounts to those 4 NEMA 17 holes and holds the motor. And for the bottom mounted part, or like the bottom position here, we hold the motor from the bottom, and for the upper position, we mount it from the top. I think that would work. So let's just project. Let's actually make this as a new sketch. I don't want sketches to be too complicated. So it's always good just to keep things a bit separated. So we can just project this shape here. This is kind of like the important part. Can you just not make a hole for the motor heads? Yeah, that's kind of like what I'm doing in a certain sense. So this is the motor shape here, right? So my idea now would be to just, yeah, add an offset here. I don't know, like we don't have to make it huge. Tolerance times 2, something like this. And now we can just kind of like completely cut this motor shape out. Like on both sides. And we just completely remove that. Like this. So now the motor kind of like falls through. And now what we can do is we can model like a new part that mounts on those 4 holes here. And this will have basically then just a threaded insert here in the center, where you can mount the motor from the bottom, and like if it's on the other position, you mount it from the top. Halfway through the thickness of the part, I was saying only cut it enough to make the motor fit in from the bottom. Yes, but we still need like something to thread into, right? Because like you don't have a thread here, so you need the screw to go somewhere. So if we have to add anyway something, because like we are limited from the back, right? You didn't see that yet. Actually, we have a bit of space here, right? But this gray part needs to fit through the hole. That's a bit of a limitation here. Okay, let me quickly model what I have in mind. I'm pretty sure that it works well. Oh shit, I put all the sketches in the wrong component. Ah, I hate it. This sometimes happens. And then Fusion doesn't let you move them sometimes. Let's see if Fusion is kind and lets us move this sketch to this component. Ah, Fusion is a nice person today. Because sometimes then it says like detected downstream changes and you can't move the sketch and you have to redo the sketch. And I mean, most likely there's a way around that. I'm just not talented enough to know that way. Oh. Distance to object. The moment is so bad. Nothing that you were the wrong part all along. Yeah. I mean, now it was just one sketch. Sometimes it's worse. Wait, let's isolate it actually. But it's like really annoying. Like that's like the most annoying part of Fusion. Like that you can't easily like change the sketch. Like the where the sketch is located. It's really annoying. Ah. Yeah. Okay. So let's just go here. So where we kind of have it complete. And usually what I do is like I model the bodies in one component and then I pull the components apart later. Like I don't know if this is good or not, but I'm not a professional. This is how I do it. So let's basically it's like a square. So we have two squares, basically. Now basically this will have just the 4 holes for the name amount and the 2 holes here in the center. So let's just constrain that somehow. Maybe we can say that the center of this hole is in the center of this. And we can say that the center of this what is this center here? I think it's the center of the motor. I'm not sure if that is smart. Its model is around the center of these two, because that's kind of like what our square will be around. Now we can just say, first we can say like how thick should that be? Let's just say like this goes 5. And then my favorite, symmetry. So you are symmetric to you? No, that doesn't work. Let's just create like a helper here. Symmetry. You are symmetric. Wait. Let's try again. You and you are symmetric along this. You and you are symmetric along this. And you and you. Oh, we need another one. Not sure if this is the smartest way to do that, but it will work. You and you are symmetric. No. Symmetry. You and you are around this, and you are around this. Sure that this is connected here. And yeah, now basically we just need to define the width here, which let's just say it's the same as here. And now we should be fully constrained. But I think we need more than 5 here actually. Let's go with 6.5. This needs to be a bit beefier. The reason is that we need threaded inserts here, right? So we have threaded heat insert diameter, which is 4.7. And now we can just say circular. We can attempt to say circular pattern. around the center point here, and we need 4. Let's actually do that later. So we have this, but then we also need to have the mounting hole here for the center piece. So let's create firstly like this here. Just create a small helper point here. And again, this doesn't need to be super tight. Let's just say tolerance ×2. It's not perfectly on top of each other, but fine. We also need to have that anyways modeled here. So let's just quickly I'm not quite sure if this makes sense what I'm doing, or if it's clear what I'm trying to do, but heat insert diameter. Yes, that fits perfectly. Okay. So here's my idea. Let's actually show the motor. We have this very beautiful shape here. And we extrude it out. Let's just do a random amount for now. Oh yeah, let's actually do have a circular pattern here around that center point. 4, okay. Because then we get like the proper diameter here already. Okay. Oh. We also need this filled. So now basically we need to figure out what the height for the top is and for the bottom, right? And we basically like one motor will be mounted on top and one motor will be mounted from the bottom. So if we, and now I've selected the top components, I will forget to activate the other component. If we look at this pulley, right? So this is the top position. So let's just model with this top position for now. So basically the motor, like this extrude, needs to go to the bottom of this plate here. Oh, we need to, there's the problem. Okay, let's update our sketch here. We can just add like something like this here. Let's just mirror that. Actually, we need to mirror also this. The sketch is way too complex. Need to mirror that over. Now I saw like there's like see here, this is not fully constrained. It is now, okay. So we also need to extrude this, like these little ears, and we don't do this in the center. And then we don't do join, we say this is a new body, please. Okay, let's actually just give this like some colors just to make it a bit easier. So this is black, whatever. Let's just say this is blue. So now here's the thing, Rivonic. So now we can mount this from the top, right? But for the lower position, we know like this will be 8 millimeters below. So we can just take this little ears here, left and right, and we say from object. Now we just have to quickly hide our bodies, then we can select that. And we select this like tab here. We say offset. Let me just quickly pull this over here so you see. So we select from this mounting and we say offset 8. Oh, we actually need to, we need the top. Offset 8. And then we need to show our body again. And distance to object, bottom of the body. And Fusion says not a thing. Wait, let's quickly reset. Let's quickly also measure. So if this motor would be 8 millimeters lower, yeah, this is fine. Okay, so basically for the bottom position, where the pulley is on the bottom position, everything needs to be 8 millimeter down. So my idea is like right now we mount it from the top, and for the other side we mount it from the bottom. So the motor is on below that part basically. Let's just try to make Fusion understand what I'm trying to do. So let's extrude this little tabs here. Oh, by the way, the motor also collides there. We need to fix that in a second. So we take those tabs. And we say from object, which is the top, but then we imagine this would be -8 down. And then we say, just for testing, yeah. My Fusion is almost dying right now, not sure why. So here's like little tabs we create. We just say to object, bottom, but this doesn't compute. Let's see what happens if we select. It doesn't want to do that for some reason. Okay, let's just make something ugly and just do that same 8 millimeters. 4, something like this, just like to have the part. So now we can print it on this surface, and we have two mounting options. We can mount the motor below or above. And if we mount it below, it will be for, like above will be for this position and below will be on the other side. Just like to quickly reiterate that. If I unisolate, right, like on this side we are now aiming for the top belt, but on the other side we need to aim for the bottom belt. So on the other side the difference here is 8 millimeters. So on the other side, the motor will now sit 8 millimeters lower. The only thing we now need to do is like, there's still a collision here between the motor and that thing. This is a mighty complex sketch. Wait, where's the... Let's actually do that as a separate operation. Oh no, there is no collision. Oh, there it is. Okay. Let's just make this a separate sketch. So we project this thing here. And now we just need to make sure that just select all lines around. I'm not sure if that worked or not. But let's just create a circle here. We just complete the circle. And then we can just say offset tolerance times 2. And now we can just... Yeah, that's exactly what I not wanted. Now I have like tons of teeny tiny circle pieces. So we just select all those amazingly small pieces of our circle. And then we just extrude all the way through. Fusion doesn't like that. I can't say 2. What happens if we just say all? Okay, yeah, it also works. Now we have this bit odd shape because we have this like weird corners here. Maybe we can get rid of this like edge. That would be nice, right? You know what I forgot? Neo, it's the same moment again. Wrong component. But still, like, we are lucky again. We just have to repeat this arguably very annoying extrude. Oh, and I accidentally removed the offset. Tolerance times 2. Okay. Let's select all our pieces again. But then I think we are ready to kind of print stuff. So here we say all, cut this direction, okay. But then let's do another extrude and get rid of this like teeny tiny weird corners here. So we just say extrude to object, and then let's just like select the bottom here. Now it looks much nicer. And this is our little motor adapter. So now we can mount our cheap ass stepper on top of our nice NEMA 17 plate. The only difference is that like with the cheap stepper, right, like the pulley here is positioned for the NEMA 17, so the pulley just like is like ever slightly further back, but this doesn't really matter. One thing to check now is like the back of this like slider thingy to here allows us 8.5 millimeters of adjustment. We said like we aim for 6, so there's this one extrude here where we prolong everything. Here, this one. So we had this at 10. So technically we can also just be smart, right? We say object. So we just select this, and then we say 6.5. Oh, but this doesn't include this. Wait, which one was it? Maybe I wonder I should start naming those. Yeah, here we say 8. Technically, would be nice to have a parameter for that, but here, this one. So let's just say object, this edge here, and then we say distance 6.5 plus 8. That gives us 6.5 millimeter of adjustment space plus the 8 millimeter here. And now I'm thinking like most likely we don't need to have this as 8 millimeter, right? Like this backplate. We don't need 8 here. 5 is enough. I don't think this will bend. Let's put one extra millimeter just for like security. Let's put 6, and then we can say this one is 6, and then like it just becomes a bit more compact. Oh, we need to pay attention here. Okay. We destroyed the holes just now. So let's just keep this. But then we just say 8 millimeters here. And we just adjust it manually. No magic, but... And then this one... No, not this one. I always forget which one this extent is. This one. So this is 8. Did we close this off? I'm so sorry. Here we said 6. And then this face to that face is... Yeah, so now we have 8.5 millimeter adjustment. So we can search where we extend that. And instead of 8 millimeters, we just have to do 6. So then like the overall adjustment range is down to 6.5 millimeters. Yeah, so 6.5 millimeters, this black part can slide back to tension the belt. Okay. So if we model this right here, so now I'll have the thread back here. And this is still like a mighty wide bridge. Maybe instead of 135, I mean, it's a 45-degree overhang. Let's just do for 145. So it's like 55-degree overhang, which is a bit on the edge, but it still should print okay. Maybe let's do the middle. Let's do the middle. Let's do 140. So it's a 50-degree overhang. And then you have this bridge here, which is, it always looks huge in Fusion, but it's only 2.5 centimeters of bridging. So it should be fine. We print on this face, we print. So basically you have to flip it, like flip it. Cool, this looks like a really cool part actually. So let's quickly look how this looks overall. like after we put everything together. And we still need to model this knob here, but we can basically start printing first. And then there's like this chamfer, like I'm chamfering all the things. So we need to add a couple of chamfers here, of course. So this, you get a chamfer, and you get a chamfer, you get a chamfer, you and you get a chamfer. Now the question is, do we also extend this black part a little bit out? I'm not sure if we should, because then everything grows, right? We extend this part, this part, this part. So I think it's fine if this is like standing out a bit. I also have these these parts already printed, so I don't want to reprint them. So let's keep this like this for now. Let's not chamfer this here, but we can add some chamfers here. So also add a chamfer here, here, here. And similarly on the bottom. Here chamfer, here chamfer, here chamfer, here chamfer, here. Cool. I like this part. Now what we can also do, we can also add chamfers here and here. Not sure if this makes it look better or worse, but yeah, looks worse than just like a straight corner. Okay, let's lock this in before something horrible happens. And then we have the rigid group, which I just use to keep everything together. So let's just quickly update that. Then Fusion is happy again. And then this would be our part, like with the end stop and the motor. And yeah, this doesn't align, but just, you can ignore that. The only thing we also should quickly do is we need to add some more components, right? So this part here, this one, let's just call that, so we just say right click, create component from body. This is the, so here's the thing, like I have this like E tag here. This is like for parts that get exported later as STL or step files. So it's all automated. So this is then the corner left motor mount. And then like in brackets, basically we specify the export orientation. So in this case, we need to flip it 180 on top. So we just say 180, 0, 0. So X 180 flip and then XY 0. And then we also have this body 7 here. We do the same. So this is E corner left. Yeah, actually we need to have left and right here because it's a mirrored part later. Left, how is it called? 28BYJ 48 adapter. And also this one needs to be flipped on its head. So it's 180, 0, 0. And we didn't model the knob yet, but we can already print the parts and then model the knob while we go, or we model it later. Like, it's not super interesting, I think. And then the rigid. Yeah, this one. Oh, it lost now here the chamfers we did on this one. Let's quickly add it back. I always like underestimate how long it takes to model parts like this. And let's quickly refresh the rigid group. Because we have new components. Cool. And then let's just quickly run my export script. And let's get printing, and then I want to build some stuff. Well, it's printing. So, exported components. If we switch to Orca, and I didn't screw up, we can just say right-click, reload. That did not work. So we need the... I don't trust my Ender at the moment to print multiple parts because I have really stringing issues a bit sometimes. So... wait, where? This one should be the right file. Oh, interesting. That's not what I wanted. Now it exported both of them in one go. Let's quickly clean this up because like this is not how we can print it. It's like all three body like subcomponents basically in one go. So we need those two. Let's quickly go here. We need to relocate those components out of that. Can I do that? Pretty sure I can do it. Yeah, I can only select the body here. It doesn't allow me to drag that out. Then let's do it different. Let's rename this one from this one to, I don't know, motor bay. And then let's create another component from this one. Then all three are now separate. So if we now export again and switch to Orca, now it should work. Reload from disk. It's getting better. Still one block. Why is this one block? Because all three of them are like separate components now. Otherwise we don't use my script quickly to export that, but it would be a bummer. Could you try to pull this in again? Ah, now it worked. Okay, so this is like the base part. Let's quickly slice that. It's a switch wire, so it's a bit slower. 1 hour 10. Yeah, okay. I guess there's no way around that. So let's print this. In 1 hour 10, we can fix the V0, and then we can print the other parts on the V0 in way faster. So let me just send that straight away. Like the other parts, like all the other parts of this corner piece we have printed. Like everything is here. So technically when we have this part, we can assemble everything together. And hopefully it will just fit and work. That would be amazing. Cool, okay, enough fusion. Let's fix the V0. I think that's the first good step, because then as soon as I have two printers, like we can start like iterating prototyping. And I guarantee you the V0 will print this in a half an hour instead of like an hour and 10. And the switch wire quality we'll get out of it, it won't be amazing, I think. Okay, so this is what we need to fix. This like weird ass extrusion issues. So as I mentioned in the beginning of the stream, It's kind of like side quest in a certain sense. We need the machine to, like the V0 to prototype. We need to fix V0. I would just rebuild the entire extruder. That's kind of like my idea. We received this integrated drive gear today. By we, I mean me. I sometimes talk about myself in a second person. Something I picked up from my job, like where you always like the team did. So it's like, if I know I say it quite a lot. So it's like integrated. So this is like one piece. And this is supposed to be much more precise than what came before, because usually you used a grub screw, right, like to secure this drive wheel here on the bottom. But the grub screw basically pushes this entire thing off the main axle, like ever so slightly. And that means that your diameter around the main gear varies along the rotation, basically. So you have inconsistent extrusion. I'm not quite sure how much this really makes a difference, but seemingly it's quite nice. So let's see. I quickly leave the V0 here. I'm just pulling off the print head really quickly. It's actually, maybe it's better to do that here. It's not plugged in. A wild V0 appeared. Let's quickly get this out of here. I hate disconnecting this cable. Like, it's such a pain. I'm not eager to do it again. Okay. Two front ones. And then there's the one hidden in the back. And at least we can pull and yank on this cable without putting pressure on the tool head mount. Yeah, this is like, I don't know, like I have the same on the switch wires, the same connector in the microfit. It's super hard to pull off. You really have to wiggle it free. I'm not sure if I'm doing something wrong with those. And it's not like a notch anymore, by the way, if nobody's wondering. Oh, let me also, second, I can do this in parallel. I'm multitasking. Let me put you maybe 0 here on the switch wire on the side. Oh, it's printing. Hi, Stefan. I once ripped cable with these connectors. Yeah. I'm not sure like why they have to be this tight. But yeah, you can't pull on the cable. I mean, it's coming out. It's just like really slow. Ooh, okay, 1 second. My hand needs a break. Yeah, almost. I hate it. This is really the worst. There must be like a trick to it. Like I can't imagine this being per design this hard. Okay, 1 second. I also hurt my hand today in the gym, so this is not really helping it. It's actually one of the reasons I switched my V0 to Can. Yeah. I mean, right now it's like horrible. Like, here we go. Woo. Okay, let's get rid of this. Like, it was also like, it would be nice to have canvas here. Like, I'm kind of tempted. Okay, let's quickly observe also what the V0 is doing. I can't say V0, but switchfire. By the way, I have no clue what profile I use to slice that. Quickly double check. I have, yeah, that's the correct profile. This is the correct profile. We can continue with this profile. Okay, so last time I rebuilt this, I made a complete mess. So maybe let's try to be a bit more efficient. Once the first layer is down, I will quickly go check in person just to see that like everything is in order. Okay. That is layer 2. Let me quickly check, and I'm right back. Bit close to the bed, but it will be fine. Like these are prototyping parts. Like I will print it all again anyways, so I don't really mind. Okay, let's try to not rip any connectors this time. I also actually yesterday I figured out that like this latch was super loose, and that again is like in turn caused this part here on the side to be like not putting proper pressure. And I first thought it was the extruder problem. I was like, oh yeah, easy fix. So what I ended up doing is I added a bit of Loctite to those two screws here in the front, because I feel like that the just like printing movement like rattles them loose. So definitely do that again. Just a bit of shame that like I just put it in yesterday. No, I like day before yesterday actually. So okay. Or maybe we actually don't have to open, like these two screws have the Loctite, so maybe we don't have to open them at all. That would be cool. See if we can fiddle this out. Nice. Okay. So just as a comparison, I really hope this is a problem, to be honest. This is the old part, and you see it has the grab screw here to hold on the bearing, and of course this grab screw pushes this wheel like more in this direction, basically, right? So the gear here is not completely concentric to the shaft in the middle. The new one doesn't have the grab screw. There's no grab screw. It's pressed on. And this means that the gear here is completely concentric to the shaft. So this one, basically as the gear rotates, the diameter changes. And for this one, it's completely concentric and the same. So this one should give like more even and consistent extrusion. Not why I change it now, but hopefully this rebuild of the extruder will also fix our problem. So I'm just checking, because I read that the bearings changed seemingly, but for me, like I can't, like it seems to be the same, like it's the same diameter. I somewhere read that like the bearings are like a different diameter, but it's fine. The thing is just like there's one bearing down there. If I don't have to get this out and put a new one in, then I'm quite happy. The only thing is, yeah, we can also take a look at this here. So I'm kind of like thinking that the gears are slipping. or like the filament is slipping between the gears. So I just want to check whether we can see some wear or something on the extruder gears here. Let's see, can I? How close can I bring this? Quite close. I mean, there's a lot of gunk in here. But it doesn't look or feel different than the new one, to be honest. I do have the new set. Let's quickly check if this is the same. If yes, I will just like swap out the part. You know, just to be sure. Like if I now have the part, let's just swap all the parts we can swap. This does look to be the exact same. This one has a grab screw. This one does not. Let's just swap that in as well. And then we have like new wheels on both sides. Let's just try to not mix that. So this is this part, this part. This is the new one. Let's just quickly clean this. Some tiny bits of filament here. Let's go back in. So this is new. This we put aside. This is new. So this is all new. Let me make a note that this one comes from the LDO kit. Not that I don't completely mix stuff up in case I want to swap it back. Put this here to the side. Okay. So now my headset died. 1 second. Let me fix that. It's like always midpoint of stream. Just come back. Is that from the 0.2? Yeah, that's from 0.2. We are fixing the extruder, hopefully. We are attempting to fix the extruder. But actually, right, like this is the tool head we will use on my printer. Like this is the mini stealth burner Bowden. So the bottom part of those two extruders are exactly the same. Basically this one just doesn't have the extruder part. Like the hot end part is exactly the same. The fans are missing. I actually received the fans. We can also put that together. And then here we have the cheap ass Creality hot end, where here we have like the Revo. But besides that, like the bottom parts are exactly the same. You also see the mounting stuff is the same. This one, this one. Oh yeah, here. This one is here. So these are the same mount. Also from the front. So the printer we are designing, you can just put on the mini stealth burner as like direct drive, which actually I might do like in some upgrades like later on. Like I kind of really want to build this printer as cheap as possible, and then like step by step, like kind of like make it nice. So, but back to this. I kind of want to make sure there's no gunk in here, which is easier said than done. Because like something makes this not extrude properly. So something is wrong, and I'm not quite sure what. Because now it's second iteration that we try to fix this. But now we have new gears. We kind of took it apart, we take it back together. So let's just hope the Voron gods are in a favorable mood. This was not the correct screw. I think it's the long one here, right? Yeah, it's a long one. Let's put the screw back in. And then we have our new integrated drive gear. So let's drop this here. Oh, but this is rubbing. Now the bearing's different after all. No. Okay, so this is kind of like at the moment sitting completely on the printed part. Whoop, I lose my plaster. 1 second. But I think like when you put in filaments, this will be pulled out a bit. Because like if you look here, like kind of look inside, if we align the two grooves, you know, like this is the bottom out position, but if we align the grooves, like this is like no longer in contact here on the side. So I'm pretty sure it's fine. Looks really nice. Thank you. I'm so glad I made it to live. Made it to live. Yeah, welcome. Welcome, Reds. Cool. Yeah, so I think this should be fine. So let's just kind of like put it together, feed some filament in, and try how it feels. And I also want to see that we have like proper like tension on the filament, like that you have the marks from the wheels, basically. Let's see. Let's keep those two. We have our extra 2 bearings. Let's just keep them here. We might need them. Let's just put the bearing back here in this plate where it belongs. And then let's put everything back together. And we didn't break a connector so far, which is amazing. Last time we broke a connector while like rebuilding this. Cool. Let's just quickly mount the motor, but like let's not worry yet about meshing. Always a bit fiddly to put this motor on. It's kind of shielding on the switch wire a bit, what it's doing. Okay. Actually, let's tighten this properly, that we pull the motor on. Okay, we didn't check meshing yet, and it's like completely tightly meshed, so we need to fix that definitely. I don't have any filament. I should have set some filament aside. Let me quickly grab like a couple of centimeters of filament that we can like run it through the extruder. I'm right back. Okay, we have some filaments. Let's just grab like 15-20 centimeters. Hey. Please be nice, go through there. Okay. So, see. Oh, we're missing some crucial part here. I should pull the camera a bit more over here. This is now, let's just tighten this all the way for a second and then like back it out. Like 1.5, 2 turns. This closes okay. Like this is now quite stiff because I put it quite tight on Wednesday. But it's okay. So let's split straight. Just quickly check that everything is aligned. It's a bit hard to see because it's black, like it shows the perfect color. But it is running in the groove here, like you see it there, poking in. So this is okay. Oh, let me quickly put in the screws here from the front, because otherwise our hot end is completely loose. So if I now pull, it's back out a bit. Yeah, you see like the gear spins. Actually really hard to see on video, but it spins. And there's quite a bit of resistance. And we do have teeth mark here. Like there's like markings on filament. So, I mean, this is functioning properly, as far as I can tell. Right, screws falling out. So this is nicely aligned. It has a really good grip. We have light teeth marks. Like this is like, as far as I'm concerned, it's good. So here's the thing. I'm low-key not concerned, but I'm suspecting that the nozzle has something to do with the problems I'm seeing. This nozzle has a really interesting history. Like I clogged it like more than once with like, I don't know why or how, like, it was just clogged. And I kind of feel like that if I use, I also have a 0.6 millimeter nozzle, and I didn't see that extruder issue with this nozzle. Like I tested it, and for some reason like it didn't stick to the bed and everything, but like I didn't see the issue with this nozzle. So if we now still have that issue of like just like rebuilding, tightening everything, maybe I need a new nozzle, which would really suck because they're quite expensive. So let's see. Let's just put it together. Let's just print like one of those like squares again, just to see that like it's kind of like doing okay. Yeah. That was my camera. I already forgot about the cable. Wasn't paying attention. Did you check the groove aligns with the filament path? Yeah, it does align. But it's also like, because it's like integrated gear, like you can't adjust it anyways. So if it wouldn't have aligned, I wouldn't have quite, I wouldn't know what to do, because like it's just like it's a fixed distance. Like you know, like with the original ones, there's like the grab screw, so you can grab, like release the grab screw and like adjust the position of this like metal gear on the shaft. but because the new one is like pressed, like you can't adjust it. So yeah, like I mean, it wouldn't work if it wouldn't align, but I wouldn't know what to do if it wouldn't align. So let's see. Yeah, let's just throw it on, and then like reattach this ungodly cable. I like this. I'm going to build also Core XY from my old duplicator i3 scraps, only going to source the aluminum extrusions, 3D print the carry edges. Yeah, amazing. I mean, like in the end, like you don't need a lot to build a 3D printer, right? Some steppers, some movement system like linear rods or like rails or whatever, some steppers, a couple of belts. It's kind of amazing like how simple those machines are in the end. Okay. Yeah, I guess. I really hope I don't have to loosen it again. I also feel like, oh, we didn't tighten that. Oh, we didn't check the meshing. Oh, okay. That's... I forgot to check the meshing. Okay, let's quickly loosen that again. And it's kind of like an important step to check the meshing. Are you printing test on the screen? No, yeah, that's the prototype part we're doing at the moment. Like we are building this and we are printing this part I'm highlighting here, like this like whole section. That's what we're printing at the moment. And then once that's done, we can print the next part. Like ideally the V0 is back in action, so we can print like two parts at the same time. But yeah, like we are building this motor mount today. So in the end, this will become like a printer. So basically, we already have this like x-axis is completely there. Like we didn't assemble the tool head part yet. We also still have to assemble the left and right part. Like I have new parts for that. And then yeah. So basically we have all the parts. We didn't assemble it yet. So, yep. But I kind of hope like next week we just do the front idlers. So like these front idlers here are missing. Like we have motor left, motor right. Right? Like if we do what we do today, we have the joint here on both sides. So the only thing left is the front idlers, and then we have a complete 4xy motion system that hopefully works. Oh god, I regret putting this cable halfway in. Like this can't be normal that it's like so... Actually, like, let's try to do it without removing the cable. Just need to loosen this screw a bit. So I can move the motor. See if we can even put it down. So we need to check the meshing here for the wheel. Gear wheel. Not loosen enough. Okay. Maybe a bit too loose. So I basically just want to be able to barely move the motor. Yeah. Something like maybe even a bit less, please. Doesn't really help that this back part is like not really like attached. Let's actually remove the PCB on the back. Or let's fully tighten it. Like one of the two things. Let's tighten it. Okay. Now we have to loosen the screw in front. And then hopefully like we can move the motor. Yeah. Now the motor is like wiggling a bit, which is what we want. So now we can basically move the motor a bit up and down. Well, it's exactly the same for my V0. The forcing it to unplug is just insane. Yeah, I always feel like I break something. Okay, so basically we're just trying to mesh this. So you want to have, like, if you move the motor down, like there's no wiggle at all. If we move the motor up, there's like tons of wiggle. So we just want to have tiny bit of wiggle, something like this. So basically we just need to have the motor in a way that we can move it a bit, but that it doesn't slide around really. Which for some reason, for me, is like really challenging right now. Yeah, it's still like moving too easily. Wait, we should tighten a bit more. It's also like a bit loose on this side. I don't know why it's like so complicated right now. Yeah, here we go. I think something like this is okay. We can tighten this and then double check that we still have the same amount of backlash. And we didn't change it. Yeah, perfect. I'm never sure like how much backlash is the good amount, but this seems to me to be okay. Okay. Last backlash check. We have backlash. Okay, then let's fully plug this cable in. Also, the way in is like insane. Oh, this is really. Maybe canvas is not the worst idea. Okay, but it's in. Like, as soon as the latch is in, I would call it a day. Latch is in, so let's see that we don't twist it. Get to the secret screw on back. Nope, I dropped Allen key. Let's quickly peek what the switch wire is doing. Let me quickly check that in person. I'm not quite sure if I like what I see. Okay, let's fire this up. Power cord here. Okay. While this is booting, I'll quickly check the switch wire. Okay, looks fine. Like I just see like some weird extrusion, but it won't be like a super pretty part, but it's fine. Okay, let's do the following. Let's quickly get rid of this like test print here. So this is kind of like the starting point. Let's hope it's better. Smart person would also have grabbed filament to print. Because I grabbed ABS, I don't want to print ABS open. But let's quickly slice something up. We can use. So let's switch to the V0. Let's get rid of this part. Add primitive cube. So let's just make this 100 by 100 by 0.3. And then we just slice this. So it just gives us like just a rectangle. Let's just quickly make sure this is centered. So let's print this. I quickly grab PLA and then hopefully, fingers crossed, it's fixed. We have some beautiful yellow PLA. Put this on the tool holder in the back. And quickly feed it through. Yeah. Let's quickly wait until this is heated up. And kind of like put some like right smack dab in the center of my table. I'm not quite sure how long I don't think it takes long to print this like thing. So let's just wait for that, I guess. And just quickly clean up a bit. The bed is at 50 degrees out of 60, so almost there. Let's see. I will be very sad if it's not fixed. And I think like the next step really would be like to replace the nozzle. So basically like the story of this nozzle is like I had like the weirdest like clogging issues like quite consistently. I'm actually like not a big fan of the Revo system by now. Because like I especially with the 0.4mm nozzle, I had so many clogging issues. Where I mean like what do you do, right? Like the nozzle is like 25 euros, so you kind of like spend like an hour trying to declog that stupid nozzle. Whereas if it's like, you know, one of those like cheap like MK8 nozzles or something like this, you just throw out the nozzle and you put in another nozzle for like €1.50, and it's just like case closed. And you just don't spend the time, or you don't have to spend the time to fix that. Because if I have the choice between like an hour of like cold hot pulls and like trying to unclog a nozzle and like just like putting like a €2 part on the printer again, like I choose a letter like every day of the week. Don't you also have the 0.6? Yeah, I have the 0.6. And I did not see the same. Yeah, I forgot to reject the filament before unplugging it or like unscrewing it. I didn't see the same issue with this one, but with this nozzle it didn't stick to the bed for some reason, so it was also like a bit weird behavior. So let's see. We can just observe now, like the bed is not level. I'm fully aware that the bed is not level, but if the extruder works, we can quickly level the bed. If you have clogging issues, did you check the temp of the heat core? Mine was broken. Temps jumped like 20 degrees and more. I don't see anything on the graphs. So like I checked I did the PID tune actually. The graphs look stable. So just to quickly. My macros broke again. Very sad. Oh, when I have Orca open, sometimes it doesn't work. So this is like you kind of don't see it because it's behind the thing. You see it here, right? Like it's quite stable behind the chat. Like we don't have crazy jumps. I can't say that it's not. The sensor can be broken as well, right? I was actually considering that. Like, why did I consider that? Oh yeah, so here's the thing. Like, what I have, so sometimes it was fully clogged. The nozzle was just completely clogged. I couldn't like push any filament. But what I had now like twice already, I would say in the last 4 or 5 weeks, is that you could push filament through the nozzle, but the force needed was insane. Like it was like at 270 degrees with PLA. Like I just put it to 270 and I can barely push it through by hand. So just like tons of resistance. So I was like considering whether the temperature was not correct, like that the temperature shown or like the temperature nozzle or the heat core reports is not there. So I was thinking of that. But then like on other times, like it was just like quite consistent. And then it just went away again. So it felt more like a clock. I've tried a bunch of nozzles. I really like the bamboo ones. They're really cheap and reliable. Yeah. I also see like a lot of people put like the bamboo hot end in their like Voron printers and whatnot. Which is also like an interesting thing. But so far it looks good. I don't see any problems so far. So far, it's good. As I said, like, I mean, it looks even level actually so far. It's a bit too close, but that's details. Okay, you have jumps. Okay, no, I definitely don't have jumps. Like, what I consider is like that the entire like offset is wrong or something like that. How high did you push the temps and was it PLA? Not that you crystallized. That was just like because it was clogged. Basically, I just tried to burn it out. So I actually put it to 300 in the end. Just like, you know, to flush it. Because I was looking for like advice online how to or unclog the Raven nozzles. Because it's actually quite difficult. And yeah, people suggested like to just put it to like 300 degrees and flush it with ABS. Which I did. But I also like run some PLA through. It was not for printing. Just like, you know, like to try to get rid of it. And it got more clogged off than, no, like it didn't get worse or better. So it was just, I was just trying to burn it out. But yeah, it did kind of work. Like the things like it worked again. At some point, like I was like pushing like filament like crazy, like different temperatures, different materials, hot pull, cold pull. And at some point it worked again. Don't do that with PLA, it just makes it worse if it's stuck filament was PLA. Yeah, maybe. It didn't get better or worse from it, so... But yeah, like, it looks good so far, right? Like, if you compare it with what we had, right? Was this direction. So we already had, like, plenty of skips in the... Uh-oh. Maybe I shouldn't have said that. Let's see if that's a fluke. Okay, so if this is the only one, we still run it again, just to be sure. This could be also something else. Just making sure the filament is like rolling and everything. Oh, this looks okay. Looks really nice. Yeah, except for this. The temps are still stable. Temps are rock solid. Like jumps between 224.9 and 225.1. Like 0.2 degrees fluctuation, which I think is kind of like normal. Okay, so we are a bit too close to the bed. So what I would do now is like, let's run this again. Just the same print. I mean, it takes like 5 minutes, so it's not even like we are printing now 10 minutes with like the preheat. Yeah. The print is like, oh no. This is so weird. I mean, it's better than before, but it's not gone. That's way better than with the MK3S. It jumps like 2 degrees even though I pitch tuning. Yeah. I mean, it's better than before for sure, but we still have like two incidents here. And also like here you see the color is a bit different, so it kind of like dragged. Let's quickly try it again. I put it up like, let's say 0.02 millimeters. Peel it off. And just print the same thing again. If we have again skips, let's try the different nozzle. Like let's try the 0.6 nozzle and see if that makes a difference, because I think from my testing so far, I didn't see it with the 0.6. But then I can't really print the printer parts with 0.6, because like even if you print, like you can print like a file sliced for 0.4 with the 0.6 nozzle, but you lose precision basically. Do you have the correct thermistor configured? Yeah, I mean like it worked for like, where do I see that? It worked the last 600 hours. So I think if the wrong thermistor is configured, I would have noticed at some point. It only started like a couple weeks ago. So try it again. If it happens again, you can change to different roll that has this filament is just bad. Yeah, but like the thing is like we had it now with 2 different filaments, right? This is blue, this is yellow. This was like what I did on Wednesday, and this is what we just did now. We can try the ABS. Maybe it's the PLA, I don't know. Like this is the same material technically, it's just 2 different rolls. But also that, like I printed like 2 rolls of that easy so far without problems. So I'm not quite sure. It's just weird, like it just started without anything really. Oh, it's already different. Yeah, but same, it's both the same PLA. So let's try the black ABS. No, and it didn't change any like slicer settings really that could impact that, or temperatures for filament, whatever. Like it's all the same. But let's just do the following. Oh, I scrolled our switch file camera accidentally. just for sake of time, let's speed it up by 50%. Let me actually... put you like a fixed focus so the printer doesn't mess around. Oh, didn't I? Yeah, put it up. I'll just put it up a little bit more with set offset because it's still like quite close. Yeah, I see it. Yeah. Oh, but now it's completely crapping out. Now it's completely crapping out. Okay, let's quickly pause. Like now you see it like here, right? Like it should have been here, like it completely... Yeah, it's exactly now, exactly what I described. So wait, oh. You see like here on the bottom, the filament. This is 225 degrees. PLA, I can barely push it through by hand. There's no skipping steps on the extruder. How high are the temps? 225 degrees. So it's already like for PLA relatively high, I would say. Might be heat creep. I mean, might be. I mean, the cooling fan is working fine. Like, I don't have any reason to believe the cooling is not working fine. Like, the fan sounds okay. Like, I mean, it doesn't push like tons of air, but it's also 30mm fan. But also you see here, like, the nozzle tip looks totally fine. If it wants to focus. Like, it's a totally fine nozzle tip. So if it's clogged, I would also expect that the nozzle tip kind of shows that, right? Wait, let me, can I? Here, like the nozzle tip looks super fine. And it's perfectly round all the way through. You do have like the marks of the extruder here. See it here? So this looks all fine. That's like what's really baffling to me. Like, it's just like I don't see what is wrong. Like, it's super hard to push filaments through that nozzle. The extruder works fine, as far as I can tell. But I can't observe this nozzle. Like, I don't trust the nozzle. Is the filament scraped away? Maybe do a cold plug when filament reaches 100. I did 20 cold pulls, at least. I did plenty hot pulls. Like, I'm out of... But let's do the following. Let's try two things. Let's try ABS. So we just... I mean, we can just do it on the fly, right? I'll just put the hot end to 250. But I can already tell you from that, like, I'm not going to be able to push the ABS through. It will be the exact same thing. So I'm thinking the nozzle is just toast. Let me just... Let me show you that from here. So I'm just pushing the ABS. And now it flows again. But you see it's curling. It's definitely blocked. Like you see. when I push it through, how it's like curling up on the side of the nozzle. So it's definitely clogged. If it would be if there would not be a clog in the nozzle, it would just pour down, right? But now it's like, I'm not quite sure why it doesn't focus here. But it's just like curling up on the side, so it's definitely clogged. Okay, let's just, let's just do a cold pull. I swear I did like many. So you do it at 100 degrees because I always did it at 85. Let's try yours. Let's try 100. So I just put the nozzle to 100. Too little tension. Yeah, it also has tension, right? Because on the filament, you see the marks, like where the teeth grab into the filament. So it has proper tension. Like you can feel it, and you can't see it on camera, but like you really see like where the extruder grabbed the filament. So it's fine as well. But it's really strange to stop extruding without skipping steps and scraping off the filament once both should happen. Yeah, technically. It's also like what I'm really weirded out about. Like, because I would expect, I mean, you see a bit that it eats into the filament, I think. Like there's a little bit like a area here where it's like a little bit like dug in. So potentially it's just like eating it in. But there's something stuck. It should come out straight, not side. Yeah, exactly. Like as soon as like curling in any way, like something is in there. I yanked at 60 even, but I would not recommend that. I would yank it at 60, but I think the filament will just break. We are at 150, by the way. Just give this like some final push. That's like already cold. Your other printer looks like it's skipped. You mean the one that's printing in the back, like on the side? Looks fine. The camera is quite shit. It's not a high-end camera, it's like a €5 camera. 120 degrees. So let me just kind of like get mentally ready for pulling that. So I'm kind of like moving the camera to the side in a way. Maybe put the camera in front and I can pull from the top. And also grab some pliers. Yeah, that part looks a bit weird with the quality. Yeah, that's also what I wanted to check there. 100. Oh. Okay. So we got a bit of yellow filament on the tip. But what looks a bit weird is it's very uneven. There are little pockets. And here, yeah, it doesn't look like very smooth. That came out too easy, yeah. That was like at 100. Let's do the following. Let's heat it back up to 250. Push, or like 200 is fine, I think. Let's heat it to 200. And then try again at 95. But I'm 100% certain something's wrong with the nozzle. 75 doesn't work, I can tell you. Like I usually do it at 85 and the filament breaks if you do it at 80. Because I tried that. Like at 80 basically the tip stays in and the filament just like snaps off. And push a bit while it's cooling. Yeah, I missed that. Like usually I push from, yeah, until it's like 150. Okay, let's, oh, but it's already coming out way better. Wait, can I actually use this to focus? Oh, it's, I accidentally touched the screen. It's coming out way better already. Like this is a bit cold for this filament, right? It's only 200 degrees, but it's not curling up. Let me just quickly try 250. Let's let that quickly heat up. Maybe this did something. But even if we are now like getting like proper extrusion, this nozzle is out. I spent so much time that it's not worth my time anymore to like debug this nozzle in a certain sense. It never broke for me, but I don't pliers. I don't know, like I can't pull it by hand. Like I don't have enough strength for that. But I think it also depends a lot on the filament what you use, most likely. What filament do you use? Because I have ABS here, it's the black, and I have PLA, the yellow. Do you use PETG or something? Yeah, this looks okay. Like it's not flowing super easy, but it's running down straight, which you can't really see because it's like all black and weird, but I mean, it looks kind of okay. But still, like, I have to push like crazy. Normally this should, like, it's 250 degrees. This should like go easier. Let's see what happens when we tell the extruder to do the hard work. Let me just quickly extrude, yeah, 30 millimeters. There's a bit of weirdness. I hear some pops, which means the filament must... Oh wait, it was stuck to the thing. 1 second. You see that? There's like this little blob. Right, let me quickly see if this is because the spool is kind of like here on the side. Yeah, now it skipped. I heard a skip. Yeah, you see there's like definitely uneven extrusion. Yeah, now I hear like sometimes skips. There's definitely like, okay, this is weird. I'm also struggling with cold pulling under 100C. Maybe the walls inside the nozzle are coated with some filament that crystallized. So here's the thing. My suspicion is because I used to have this super crappy wood PLA from like this no-name brand, and I printed it with this nozzle, and this was the first time it clogged. So I have the suspicion that there's still like part of that stuff just in there. Let's do the following. Let's just pull this out. I don't want to cool down the nozzle. Let's see if I can quickly... If I can be lazy, and just do it like this. Not sure if it's faster to just quickly cool it down. Let's quickly cool it down. Yeah, that might be the problem. But you know, like it prints fine, like most of the time. Like I don't know. It's just weird. But like I will order a new nozzle tomorrow. I will just eat the 25 euros for this. That's like the part that annoys me so much. Like every other nozzle, like for like any other system, you know, like the nozzle is like, let's say like you have a premium quality nozzle, whatever. It's like 5 euros, like a nice quality nozzle. but now it's like at least 25 to replace this nozzle here. See if I... Where did I put the silicone sock for the nozzle? Okay. Okay. Use this one. Just a quick tip for your printer config. Yeah, I actually have a nozzle change macro, but I don't want to wait for it to cool down. Retract filament from melts on. Yeah. Yeah, I know. The thing is, like, I struggle to have a custom macro for pausing. Like, for some reason, whenever I create a custom pause and print end macro, it doesn't park anymore. And I never checked out why, and I was too lazy. Okay, we are successful. So let's heat it back up to 250 and see how this nozzle behaves. So this is, to not mix them up, this is 0.6, and I think I lost the silicone sock for the 0.4, like the red silicone sock. Look at the trial length tungsten carbide nozzle. Suddenly the price feels cheap. Yeah, I know. But I also looked at the high flow Ravo nozzles, and they're also like 50 euros. And like the thing is, like, it's totally fine to pay that if you get enough print time out of it. But with this nozzle now, I have, let's say, like 400 hours. So per hour printing, I paid, okay, 6 cents for the nozzle. It could have been worse, but still. It's not a lot. It's not cheap. Okay, let's feed some. Let me just use the extruder again, just to see. Oh, now it's at. Let's set I heated up back to 250, but now we use PLA, so let's just give this like a second to cool down. Oh, moved it a bit more space. Okay, let's see. So we are 225, so I'll just extrude a bit of material. Nope, it has the same. See here? We have the same blocks. So it must be something with the extruder. But now it's like super consistent. Like it happens all the time. Ah, that's weird. This is so weird. Precious thing, you're extruding quite fast. Oh, that's fair. Let's try it slower. You are correct, I think. I think this filament is quite wet. I'm not sure if you can see it, but it's like puffing up. Okay, let's try the following. Let's just continue the print we started and just see what happens if we have like normal quote-unquote extrusion. The nozzle is safe for 50 millimeters per second. I was using 10 at the moment. So where we had the blobs, I used 10 millimeters per second. Yeah, so now it looks okay. So potentially I was just feeding it too fast, like in the extruder. That's fine. Let's see. But again, like in my testing on Wednesday, I didn't see the issue that I had here. Like this one, I didn't see with 0.6. I never could get past 13. I moved all printers to bamboo or dragon hot ends to have a reasonable amount of flow. And I was wrong. PLA is 13 and ASA is 15. Okay, yeah. But I need to see, but I think I do hit like 14 at least with ABS quite regularly in my printing. Like I print quite fast by now for the prototyping. And it regularly shows like 15, like not 15, but like high 13s for flow. I mean, it really depends on the filament, right? You will be able to if you print fast enough with wider and thicker layers. Yeah, I mean the 0.6 is quite funny actually. Like on the Voron Zero, I really wanted to have the 0.6, but I feel like it's quite pointless because the printer can move so fast that you can like you max out the hot end basically, or like yeah, and with 0.6 you can't move as fast as with 0.4 because again like the hot end extruder is kind of like the limit. So unless you have like a high flow hot end on the V0, like 0.6 is completely pointless. But it's totally fine. Like it's too close to the bed, whatever. But no issues. Like it's perfectly fine. Cooling is problems. Yeah, cooling is the weak point of this printer. With PLA, I really struggle with cooling. So, what to do now here? I'm nicely printing 300mm and infill at 400 V0 CVs. I'm not that fast. I limited mine to 300mm. I mean, this is very consistent and nice. Like, there's some weirdness like in the beginning, but it's fine, right? Like, let's ignore like the first couple lines. Let's try the full print again with the 0.6 nozzle. Let's see. Here's a fun story on the side. So I already ranted like last week in the stream about that, but I use Orca Slicer, and what I did not know until last week, if it allows me to change, is that in your machine settings here, right, you have that motion ability here. This overrides whatever you have in the Clipper config. So if you set like 1000 here, actually like most of them don't matter seemingly. The maximum acceleration for extruding, like for my testing, is what gets applied. Like whatever you put there will be applied here to the machine. So at the moment, like for some reason 3500, don't ask me. But like whatever you put, Orca will apply here, and this overrides your Clipper config. Because I was always increasing my acceleration in the Clipper config, and I was always wondering, didn't really get faster. It was a bit weird. And yeah, like I didn't update my Orca config. And then like basically Orca puts as the first like in the starting G code, it puts like the limit of the acceleration. Okay. Let's see how that goes. Let me just give you again like the overhead view. I think it's the best for this setup. And let me force focus. You don't know how long I struggled with missing this setting when I was trying to get a 10-min Banshee. Yeah, like that's the thing. I'm not sure if it's me, but I don't feel like that it's super obvious that Orca is overwriting your Clipper config. Like, I'm not sure if this, like, everyone's like, oh yeah, sure, that's clear. Did you change the nozzle since, like Stefan mentioned, like line width and so on? What do you... We now print on the 0.6mm nozzle. The 0.4 is out. But the line width is still 0.4. So it's like basically like we slice the file for 0.4, but we print it with 0.6, which actually works quite well. Oh, we have a print done. Let's let me quickly grab that. Mm-hmm. We have a print. This is the part we designed. It looks kind of okay. Overhang worked. Let me just quickly like throw the next part on the printer so we can kind of like, while we fix that. But it looks good. Okay. Let me... Okay, I'm optimistic that we can print something on the V0. So let's only do one part on the switch wire. Switch wire is starting to print. Okay. This looks perfect, but I already said that before and then it failed. While we do that, let me adjust the Z offset a bit. It's almost there, but let's just teeny tiny bit up. There's like one line that's a bit off. Like just here. Teeny tiny bit. You can't even see it on the camera. Yeah, and the bed is not quite level. Like you see on this side. Oh wait, sorry, I have to... On this side, see there's like little holes at the edge. And on this side, it's overflowing. So it's a bit tilted. So that means this corner in the back needs to go up a bit. Let me just do that. In line. See here where it changed the bed level. It's not fully overwriting them. It should be only able to apply lower limits. Yeah, most likely. I'm not sure. I never tried like having higher limits in Orca. So now basically I just like whenever I change the acceleration, I change it on both. So it's fine, but it's like, yeah, just very unintuitive. Seems like the top right is a bit lower. Yeah, so I put it up a little tiny bit. I think now it's fine-ish, or at least better. Doesn't have to be perfect for now. I don't know why, but I was like also on Wednesday when like I had all the problems, I also was messing with the bed level at some point. I had it perfectly level, now I don't. It's like a bit of a shame, but yeah. That's the one thing I kind of wish that like I had like a, even with a small bed, like it would be nice to have like a clicky or something on there. Just so you don't have to worry about that stuff. Okay, what do we do? This is perfect. Shall we try again with 0.4? Just like to be sure it is the nozzle. This is like besides it's not like super level, like this is a really good first layer. Like it's very consistent, nice. Looks good. Okay, yeah, let's quickly try again. Actually fascinated 0.6 nozzle works that good with 0.4. Yeah, it does. Here's the secret. The switch wire, it has 0.5 millimeter nozzle. And I sliced 0.6 and 0.4. Whatever I need at the moment. And it works perfectly fine. Somebody, I can't remember who, but like somebody made also a YouTube video about that. Like one of the big print channels. With like our 0.4 millimeter nozzles obsolete. Because, yeah, it doesn't really matter. Just like what you slice, there's a limit, of course, right? Like you can't slice with 0.4 and use like a 0.8 millimeter nozzle or something. At some point, it becomes ridiculous. But 0.4, 0.6 works quite well. You lose precision. That's one thing you definitely do. Okay, still works. You lose a bit of precision. Like if you have very tight tolerances, you don't get away with that. So for example, you can't print boron parts, for example, which have like very tight tolerances with 0.6. But like for normal stuff, like it just works. Carefully with clicky, I did slide swipe after wondering forever why the back of my printer was too far away from the plate. Turns out the switch is able to bow the bed. Oh, crazy. The video from... Oh yeah, Thomas Landro did that. Yeah, exactly. That he did the video on the nozzle sizes. Let's see. Oh, I think we can already swap the nozzle. So if we now get the same extrusion issues again, then it's 100% 0.4 millimeter nozzle, and then it goes out. Like no matter the price, if it's like eating, I always say like I have enough money, but I don't have enough time or something. It's like, I don't know. Like if something stupid like a nozzle takes me like 5 hours of work, then I'd rather pay 25 euros. Okay. 0.4 is on. I'm still not sure where I put the silicone sock for the nozzle, but doesn't matter. Let's print. There's a try zero mod. Yeah, I saw that. There's actually like a lot of mods for the V0. I forgot his name. Shame on me. Rushmore 3D. He does a double dragon. Like it's a V0 with a dual extruder, like with 2 tool heads. He's about to launch that project. There's one page. It's called Printers for Ants. And it's just a collection of small printers. There's exactly like the dueling 0, so it has 2 print heads across of each other. It's a V0 basically, but like... Then there's Double Dragon, which Rushmore, I think, will build. And then, yeah, you have the triple lead screw-ons. That's the one you mentioned, right? I have no clue what this is. V0 mod for flying gantry. Oh, so it's basically like the 2.4 motion system in the V0. Tri-Zero, triple belted. Oh, that's with belts, have lead screws? I use so many. It's like really funny. There's also, I'm kind of intrigued by, there's a project, the switch thread. It's like a switch wire in V0 size. I'm kind of intrigued to build that. It was, yeah, 3-0 with triple belt. Yeah, there's so much cool stuff. If it now works, I'm really sad because then we're kind of like where we started. I really want now to see like skipped extrusion again. If we now have skipped extrusion again, then we at least diagnose that it's the nozzle. Most likely we are a bit far from the bed now. I feel like with the 0.6 nozzle, you need to be a bit further away. Then we just directly moved it like down because like there's a little bit of like gaps in the extrusion. I just moved it down 0.05. By the way, I have no clue what the switch wire is doing. Looks like it's doing well. I would love to do a micron as tool changer, but it's already so close to the price of a 2.4 that it doesn't make sense. Yeah, that's always the thing, right? Like, like the V0 is relatively cheap in a certain sense, right? Like you get the cheap kits start at like $350, euros, whatever. But then if you get up to like a micron, like it's just quite expensive to build. So I'm still debating that with myself, but like my master plan actually is, so this is kind of like a toy. Like I'm not quite sure if something comes out of that, but I want to do later this year. I'm moving to a new flat or to a new apartment, like in, let's be optimistic, September. So before then, I don't want to build another printer because it's just like more stuff I have to move. But basically, after I moved, I want to build a 300 or 350 millimeter Trident. That's kind of my thing. Or like a 2.4, not quite sure, but most likely Trident. Because I kind of want to have one big printer. Because I often find myself now wanting to print bigger parts that don't fit on the switch wire or on the V0 for obvious reasons. And I don't have a machine that can do it at the moment. So it's kind of like one printer. And I think then I'm good with printers, and I have like 3, that's plenty. I was actually like, it took me so long to get a second printer. Like I always had the Ender 3 and I was like, oh yeah, but what to do with the second one? Now I'm printing on 2. Let's see. It still looks good. I need this to have like problems now. Otherwise I'm really like, Trident's really nice, but tap changer is currently only available for 2.4. Yeah, okay. Then you have a good reason for 2. I mean, like, yes, they're different, but they're kind of like filling the same niche, right? Like 2.4 and Trident are like kind of like very similar. Let's see. I still don't see any problems, which is not good. But I think either way, what we should have done is basically when we had the problem, with like the hard to push and like curling, we should have immediately swapped in the 0.6 and just see if this singular change fixed it. Because we did the cold pull first, and then like 0.4 was also somewhat okay. But there's still some time till next Black Week. Let's see what the community does. Yeah. I mean, for me, like before I buy like any kit, like at least like it will be like at least September. Realistically, more like October, late November, and then like Black Friday is around the corner, so potentially I'm waiting. Let's see. This is not good. I mean, there's some tiny thing here, but this might be something else. Okay, if this is done, let's print that adapter plate we need for our assembly. Yeah, it's it's successful, which annoys me a bit. Like I changed the Z offset midway through. That's like here, like it's just a bit too close. That's why it got like a little further. There's also like we kind of purged the black as well, right? Like you see, like the purge line is completely black, so we kind of purged the black out a bit around, and then like it got better. Yeah. Let's try real print. But again, like the first layer looks very nice. Like it's very smooth, like the line width is very even. Okay, let's print some real part. But yeah, I have to fix like the print end macro and the pause macro, because it's also like always oozing material when it's done, which is like super annoying. Always causes problem like on a subsequent print, like when I don't like remove it manually, like we always have this like weird thing then hanging there. Let's see. How is the switch wire doing time wise? This takes 15 minutes still. So my plan basically would now be, if this prints successfully, I would deem that fixed until the next time it blocks. But then at least I now have like a game plan. So next time, if I have extrusion issues on this, I directly switch to 0.6 and continue the print, just to see if the singular change of changing the nozzle fixes the issue. If I'm smart, I would just like order a new nozzle and call it a day. Oh. I just retract at the end of every print -4. Yeah, it's also I do on a switch wire, I think. But for me, it's also like during pause, like I can't update the pause macro for some reason. Like this causes like all kinds of weirdness. And for me, like if I pause the print, like the nozzle keeps oozing on the V0, which is like super annoying. What slicer profile did I use here? Oh, I used the slower profile. Just don't pause. Yeah, that's easier said than done. So there's like this. I love this printer, but there are two issues. Three. There's like the clocks I have, or like this extrusion issues we're debugging at the moment. There is the pause macro that annoys me, and the third one is the filament runout sensor randomly triggers sometimes, and then it pauses. So not pausing is sometimes easier said than done. What's the ETA on that? 10 minutes. So both printers will be done pretty much at the same time. Let's just keep an eye on that for now. But it looks fine, right? Like there's... I just put the speed to 125%. I'm still kind of on the fence whether I should like print that printer in ABS or PLA. It would kind of be fun to try to make it work with PLA because it's a bit more affordable / easygoing, so it kind of would fit the theme. But I'm almost certain that it would not be like good quality result. So I'm most likely going to ABS with all the parts. And this will film and run out, same issues. Yeah, I actually tried to fix it. I have a revised version of the runout sensor, and it worked okay for 3 months or something. So basically what I did, let me just quickly, while we are waiting, let me pull it up in Fusion. So I have the War on Zero mods. Yep. I modded the foot a bit. And I thought I fixed it. Like it was fine for the longest time. So basically what I did, so I added like this like eject button here, which is like super handy. That was the original mod. So you just press it and it triggers a macro to like extract your filament. And if no filaments in the sensor and you press the button, it will load the filament. So it's really cool. But yeah, you see here I angled it downward. Like the stock one is just straight. And I angled it down. Because basically what this does is... if you look at the path that the filament takes... so basically the sensor... Okay, it's not quite 45. The sensor sits here, right? There's this like bearing usually, and the sensor switch sits on top. So basically, if everything is straight, what happens is that the filament kind of curls down a bit, because afterward, like the bone kind of goes up, right, to like tool head. So the filament gets like a natural curve, like downward, and then basically what that causes is that the filament bends away from the switch. And at some point it just like doesn't really contact it like reliably, and the switch like just flickers basically. And by adding this bend down, like my goal, and it worked well for weeks, is that basically you force the filament to curve upward. So basically the filament bends upward and like pushes against the switch. That was my idea, and it worked well. Now it doesn't anymore, so I need to take it apart and just check what happens. My suspicion is that over time the filament rubs against the inner path and like just like eats away the like it widens the filament path there, and then like the same issue reoccurs where like the filament can wiggle around, and yeah, I don't know. Not a fan of the 0.2 runout sensor. And yeah, I also like I had it disabled by default, then I fixed it in the foot and I enabled it again. No, I should just disable it again, accept defeat, and call it a day. Still looks fine. Oh, I see the silicone sock. It rolled to the floor. Okay, so yeah, once it's done, let's put everything back together and see if what we did works. If so, I'm actually not sure if I have enough heat inserts to assemble everything. I'm running low on heat inserts and the new ones didn't arrive yet. But then basically what I would do is until next week, I would print all the parts we need for the entire motion system, except for the front idlers, which we didn't design yet. And then basically next week, we can quickly design the front idlers. And once the front idlers are designed, we can print them live on stream with both machines. Like, not a huge part, so I don't think it will be more than like 40 minutes of printing. And then next week, I want to put together the entire motion system, that at the end of next week's stream, we have something that moves, ideally moves under its own power. That we have like a mainboard set up with like 2 motors and we can move something. That would be my goal for next week. Let's see. How long does the switch wire still take? 10 minutes. And the V0 takes 3 minutes. Okay. And basically once it's done, let's start assembling. PLA should be fine. The 100 is working without issues. Yeah, that's the thing, like, most likely it's fine. I'm most likely what I'm going to do, that's like kind of like how I printed the parts now. I will use this blue. This is PLA. I will use this as the accent color. And for the black parts, I use ABS. So it's kind of like a mix. But I'm fairly certain that you will get away with PLA, especially if you use the weak motors. It shouldn't be a problem. Oh, we didn't design the thingy, the thumb wheel yet. I might do that then over the weekend and also print it already. I don't think it's super interesting. It's just a hex with a with a hole. You know what? While this is doing a thing, move that to the side. Move all the trash to the side. We are quickly jumping in Fusion and just design like some rudimentary thing we can quickly print. Then we can assemble it completely. Because all we need, I'm just really like just whatever. All we need, right, is like we know it's 20mm thing. Let's put the polygon, something around it. Let's put this at also 20. And we extrude that, say 10. Then we put a thread inside. Isometric. Now we have a thread. Let's throw some chamfers on that. Two. some around here. Are you sure about mixing PLA and ABS? ABS shrinks a lot more, could lead to some issues. Yeah, I mean, like, the parts fit fine so far. I didn't see any problems, but yeah, might cause problems. We now have a nut. Let's actually make this a tiny bit smaller. Maybe let's go for 15 here. 15 is a bit too little. 18? 18 looks fine. Then up. Save as mesh. Orca slicer. Before a print is, or after print is before a print, right? And next one. Here's the part. It looks fine, like bit stringing for some reason, which is odd, but besides that, it looks fine. Okay, let me quickly try to clean up the trash. I'm right back. So let's see. Should start any second. The switch wire is like 5 minutes out, and then we have all the parts at the same time. Guess we can already like take a look. So this is like the motor mount, which kind of goes in like this. So we basically have the vertical here, and then like the horizontal here and here, and then like the little one is for like a roller stack. And the second roller stack goes around the one on the back. Let's bring in our motor. This basically goes on top of here, which fits. I'm always like happy when like stuff just fits. But it's definitely good that we gave this like a little bit more like tolerance, because like it's kind of like almost touching. It's 6 minutes. Switch wire is 4 minutes. I'm curious whether the threads fit together. Also, it would be kind of fun to have a second V0. Like prototyping like this, if you would have two machines like next to each other, like spitting out parts in that speed, that would be super fun. You know what we can quickly do? Like, while we're waiting a couple minutes? Let's take apart this like preliminary assembly and quickly put heatset inserts in here, and then I'm curious to see whether because like this is a bit loose, like not sure like who was in the beginning of the stream here, but I showed that this is what we designed last week. And it's not sitting on super tight, so potentially we have to redesign it, but it didn't put in the heatset inserts yet, so it's kind of like a weird fit. Let's pop it out. Looks like it's quite loose for some reason. Like, yeah, like the bearing on front has like a lot of play. It's pretty weird. This is why it has so much play. Let's see, like once we tighten it, whether it like still has play. I'm not quite sure why the tolerances are so big there. So maybe I should check the tolerances there in the part. I mean, if this happens, you can always just put like tape around the bearing to just make it thicker. Let me see if I can get my soldering iron. Ugh. Yes, I can get my soldering iron. Then potentially with some compression this will be fine, but then this is definitely like too much play. Let's see. My soldering iron needs a bit more time to heat up. Still like very hard to push. V0 is almost done. Switch wire also looks pretty much done. Yeah, I'm really excited. Like if we next week can put together the entire Core XY motion system and it would work somewhat okay, I would be really happy. Okay, let's just put this on. So on the back screws, we have, I think 12 millimeters. Yep, that looks good. And then the front ones are, let's just put it in, like usually like there's the, actually I have the part here. We have this like tool head mount here, and I think it's like 25s, which is not this. It's 25. Oh, the switch wire is done. Zeros in the last bit. Make sure this is nice and tight. And see if we still have wiggle. Oh, now it's too tight. But yeah, still like it's wiggling. Like it's not moving up and down, but it's also wiggling. So it's also interesting that you can compress the printed bearings so much that they don't move at all. Now it's sliding up and down. But yeah, it's definitely like this is not good. If we can see that, like if I really hold this down, this is not what you want from your printer tool head. So we need to check the tolerances there. So definitely I mean, here's the thing, right? Like the up down, like it doesn't wiggle around the x-axis. Like in this direction, it doesn't wiggle. It's just like xy basically. So this open design on the back works, but the tolerance for the front one, the front bearing, need to be really tight that you don't have this wiggle. Okay, but yeah, this is then the tool head mount. Cool. All printers are done. So let's try to assemble our motor mount. Let me quickly grab the part from that printer. Here we go. Okay, so this is our... It's not super stable, but I don't think it has to be honest. Because we kind of reinforce it anyways, right? Where... here. So these are all the parts we have, plus some random screws and nuts. So the interesting part is how does this work? And the answer is it works kind of okay. Like it doesn't need to run smooth, right? So we kind of have to see if we add a bit more tolerance here. But yeah, this is totally fine. Like it doesn't need to run like super smoothly. The interesting part is what is missing on this part. One tip, it's a thread. What happened to the thread? Let's quickly check what happened in Fusion. Oh, I didn't check the modeled checkbox. Didn't check the modeled checkbox. Now it's modeled. Okay, let's quickly print this again. Well, this was a waste of material. I could have seen that also like in the slicer. Okay, I just sent it off to print. It's on the V0, so in 5 minutes we will have the part. But yeah, then basically like, oh, yeah, this goes on here, then maybe, and pulls this out. So basically the belt comes around here and we tension it. Let's put in the heated inserts here in this part, and then we can put this on top. But for just sake of reference, right? Happens to be best to miss the check. Yeah, it's quite important, right? So this kind of fits on top as well. So that was like the alternative, right? Like we have the big stepper, so you can adjust this, basically tension it like this. And then we have this adapter plate for the small stepper. Okay, let's put heat set inserts. It's a bit of a fragile part for heat set inserts, but yeah, I think it should be. Yeah, I want a bit more heat. For some reason, it's like really hard to push. 290. I want to be a bit careful to not like push the iron into my surface, work surface. Ideally, I don't want to have marks on there. A lot of heat inserts for one small part. Wait, why does the V0 not? Would have made sense to click upload and print. Now the V0 starts with the new part. Ooh. Now it's way too hot. This went through like butter. Well, it's still usable. Okay. Then yeah, let's put this on first. I mean, it doesn't really matter what screws we use, so gives me anxiety. I'm sorry. Why? Because I touch it with my hand. Like, you just need to be quick. If you take too long to put the insert on the iron, then you burn yourself. So let's see. So this would be like the one position we can mount it. But then like for the A drive we mount it like this, but for the B drive we mount the stepper from the bottom. Which we should try both variations. And then this goes on here. Oh, this goes this direction, which is a bit unintuitive, but it's a bit off with the first layer, like it's a bit hard to push. Let's use this one. Yeah, the screws are binding a bit in the blue plastic, blue PLA. It's a bit weird. There we go. And technically we have two more, but for some reason, like, they are a bit, all the holes are a bit too small. Not the same hole diameter I use everywhere, unless we accidentally only model like 3 millimeters. And you can still just drill this out and it's like easy. So let's quickly check the hole diameter in Fusion. Okay, but yeah, this is the mount. The only problem is, I didn't think about it, right? Like, you first have to move in the blue part and then you mount the yellow part. So let's take this apart again. Just bridging the time. Maybe you forgot the offset? Yeah, something like that. I assume that we either extruded the wrong circle, because usually I have this like screw diameter parameter, which already includes like tolerance. Okay. So first, oh yeah, you also have to. First, this goes in. Then this goes on top. That's a bit of like a challenge. Oh, it's actually going in quite fine. Like, oh, I used the wrong screw right now, but this screw is way too long. That's fine. Just for testing. Can you add a chamfer to the screw attachment? Yeah, I could. Don't see why not. Like, it would definitely make it easier. But I think if the holes are properly dimensioned, it will just like fall in anyways. Yeah, this works out really well actually. No. Let's see, V0 takes another 3-4 minutes more. And then we can kind of like try if this works, but I'm pretty sure it works. But like while we're waiting, let's quickly try to attach the motor from the bottom, just so that we know that also works. Oh, and I actually put it in the wrong way. Ah. Because like here it's like tiny bit higher, right? This should go on the bottom, but yeah, for now it doesn't matter. Just see, yeah, but also like that works as well. So you can. Okay, that's a bit of like a interesting job, but it still works. Yep, now you have it on the bottom. So basically this is for the A drive, and then like the top position is for the B drive. Then we have now one part, and it works with both positions, which is really good. And this like slides quite okay. So basically this would be like the furthest position. And then like basically, right, the belt, and I don't have a belt, but basically we have the pulley here, and the belt would kind of pull. Oh, actually, like I do have a pulley. Let's try that. Here are pulleys. Let's see what a pulley does with that. Oh yeah, there's a problem. The diameter of the pulley collides with that part. So basically we need to make this bigger here, because like right now I can't put the pulley on. Like it misses like a millimeter. But this one is also a 16-tooth pulley. And I'm not quite sure yet what we will use. It's either 16 or 20. These are 20s. And you see like the 16s are a bit smaller than the 20s from the diameter. So basically if we go for 16, the benefit is that, oh, and now I also see the base size is different. Oh, that's not good. We modeled with 20. So most likely we will just stick with 20. The benefit is the 16 basically trades speed for torque, more or less. The 20s have more speed, the 16s have more torque. So you kind of like, and precision, technically. Hydrophobic. So let's quickly modify that in a very professional way. So modification complete. Yeah, so that works. So we kind of have to modify the part a tiny bit. But this way. The only thing is like it's tilted. Like it's not straight. Why is it tilted? Like this should be like straight up. This is not good. Let's investigate that. What is tilted here? I think the motor is not straight on. Like the motor is like not level. Ah, yeah, okay. So I just bent it a bit. I don't think these are like quality quality parts. Yeah, see now it's straight. So I just bent the motor. But that means that we need to have a connection here. Like there needs to be something for the motor to push against. Because basically the pulley, like the belt will pull from this side. So I fear that we kind of... Yeah, it should be fine. So if we add like a little bit of like a feature here to connect those two halves. So potentially we leave it open here, but we connect it here in the back. Then basically the motor can has something to push against in a certain sense. Okay, now the moment of truth. Do my two printers work together? Yeah, it's a bit tight, but it works. But yeah, we can also shorten this, right? Like we don't need it this long. So basically now the belt would be here, right? Pulling it, and then like now you can tension the belt. And now you would be fully tensioned by adding like just like this much distance to the belt run. Like this runs a bit rough, but that's okay, I guess. Can see if we can like just add like a little offset or something. The one thing I'm thinking about is because like right now like you have quite a big like surface contact area, which most likely also doesn't help with making it run easy. So maybe it's best, I mean, we need to model like a proper part. Maybe it's best to print it like upside down, like with the bed here, and then add like a little bit of like a ring on top, that you only have like a small contact area where the friction comes from twisting. But like technically this works. Like this is plenty of play. We can shorten the, like once we have the final part, right? Like the screw section here can be shortened to the height of the screw. We don't have to have it like that long technically. And then we need to have like a little bit of like a feature here for this motor. So basically like we should leave it open in the front so we don't have like this collision with the pulley. And then basically connect it in. Technically like we don't have to have it open here at all, right? Like the entire half on the back can technically be just like filled up. Because nothing will be here. Maybe it's nice to have it open in the back, because like if the motor is mounted in the other direction, like if the motor is mounted on top, we can use this to pass through the cables. maybe that's nice to have it like a little bit open there. But I would call this a success, for sure. Let's do the following. Let me just quickly put together all the parts. I'm not gonna assemble it now. Let's do it next week. So these are all the things. So basically, this is the bottom corner, right? So this is X, this is Y, and then we have like those million of parts here, and they all are a little bit different. Like all the corner pieces are a bit different. So they only fit in one spot. This one is here, and that's like one thing we kind of need to oh no, this is the top one. This is like a puzzle. This one fits here. So this goes here. Then we have this like corner piece, which goes here in the corner. And oh, this part here. No. This one. This one goes here. So the only thing is now basically, because we extended this by like a couple of millimeters, that this isn't flush anymore. So the beautiful thing is at the moment that these parts are mirrored from here, like we mirror them along the cross axis. So now if we prolong this, it's a bit of a tricky thing for me to model the parts. Like this is how it will be, right? Like there's like this little tiny thing. So maybe it's better to just leave it and like, I just put like a chamfer here to cut off the corner. You know, just like this aligns like this. No, it's also not the right part. Oh, it is. This aligns to right this, and then like we just cut a corner here, because then like this can be still the same as this side. Let me actually quickly check which one is this. There's so many of those, and they are all different. I'm not sure if this is good. This one. So these two are kind of the same, except for like those cutouts here. And then the corner piece. And then basically we have the same one on top. You know, like there's like two on top of each other. And this one is exactly the same. It just has the same corner pieces. The same thing here. The only thing here is we have this little mounting plate for our end stop. So, all the parts. Hey, I'm late today. How's the build going? We have a motor mount, which I think is really cool. Like, it's the same tensioning mechanism as the V0. I stole some inspiration. So basically, the belt runs around here, and then like you use this like M20 thread to tighten everything, and you can like tension. And this motor mount, actually, you see like the 4 corner hole. That's the NEMA 17. So basically, you can use the NEMA 17 motors or our teeny tiny weak ass 28 BYJ. Both are supported with this setup, which is pretty cool, I think. Not many printers have that feature. Here, Jonas, just for you. This is how it currently looks. So next week, also like kind of wrapping up now. A bit tired. My voice is slowly giving out. So what I will do now, I have all the parts printed now for the corners, except those like motor mounts. So what I will do is I will print the second motor mount. Like we kind of have one now, right? Like it's not the final, like I will reprint the center parts with like the small changes we just discussed. So basically we said we model this like adapter piece a bit different, like to connect in the center, we have it open in the front so the pulley doesn't collide. I will quickly add like a proper nut. Like this one is not nice. It doesn't turn nice. So let me work on this. It's most like just like a tolerance thing between my two printers. I think the switch bar doesn't have the best tolerance at the moment. So I will try what happens if I print both of those parts on the V0. And then, yeah, I think these are the only two changes, like proper nut. We then shorten that part here and the chamfer. So it's like chamfer, nut, shorten, connection. So 4 changes. Then I print all the parts. And next stream, what we want to do is we want to design the front idlers, right? Like the only thing missing here is now the front idlers. The front idler is the last part of the XY motion system. And I don't think the front idlers are necessarily complex. They will be quite simple. It's like two rods come in and 1 rod comes out vertical. It's super simple. So we kind of built it now like 15 times. So that should be like a 30-ish minute model job. So it should be fine. Then we print the 2 front idlers on stream next time. And while we print that, we assemble the entire other thing. So basically, next time I want to have a working XY motion system. I forgot to tune in, was busy tuning printers for printing the G2 tension meter. No worries. You didn't miss too much. Like we were working on the V0 quite a bit because my V0 has a bit of extrusion issues. So we were fixing the V0. Cool. Okay. Yeah, I would call it a day. Yeah, voice is a bit weird, a bit tired. So we're already streaming like 4 hours, 40 minutes. So that's kind of like a good mark. Thank you everyone for tuning in. I'm really excited for this project. Like I think it's turning out quite well. And yeah, next time, big milestone. Like if you have a working XY motion system, I'm super happy. Working is kind of like, we need to tweak most likely some things, but it's like somewhat working. I definitely call it to win. Cool. Okay, then enjoy your weekend and see you next time.